Alright guys, so hopefully you're able to hear me, and let's get going. First of all, I'll go to the that OneNote. So guys, we're some students are saying that we have subscription disabled issues there. Now again, as from the start I was saying that it's something we're forced to go for the Azure solution, and there it's free, and but for until $100, and somehow now obviously the more underlying hardware is being used of Azure for this particular SQL lab, even for Exchange Server lab. So for these two courses, the college was also trying their best to arrange remote labs for us, but that was not technically possible for them. So then we're coming to this, and because of the circumstances, now if your subscription is disabled, then please do send me a screenshot. I've put that message there as well on WhatsApp and in WebEx, and I'll put it on Blackboard as well, that if your subscription is disabled, now there are always solutions, but the thing is that those are like very time consuming solutions, and then they need to be tested as well, that how to move the machines from one subscription to another, and how to keep moving those machines as soon as the subscriptions are done again, and then how long we're getting, one student is getting again and again how many subscriptions. So that needs to be sorted out and takes a lot of time. So we were not also prepared for that. College, I don't think there's a solution for that. So what I'm saying is that if your subscription is disabled, so take a screenshot of the disabled subscriptions, and then just email me and Cyrus and Jackie that okay, my subscription is disabled. So those whose subscriptions are disabled can actually then take screenshots of my screen with your name in the background, just like we're doing in the mail server. So this is not the ideal situation, obviously, but this is what we have right now. So if your subscriptions are disabled, then I would need a screenshot of that with obviously your name showing for your subscription page, and or college ID showing in the subscription page, not separately in Notepad or something, right? Your page, your subscription of Azure should be there. So that said, let's try to go ahead. There are some students still arriving, so if they, well, the message is there. It's in this OneNote, and it's in the WhatsApp as well. So let's go ahead, guys. With those who do have the labs still intact, can follow. Okay, so Paul says, can we just use a beefy VMs in the cloud with 4 cores and 8 GB RAM, and then just use VMware from there rather than having to set up all this networking between VMs within a VPC or VNet, you mean? So you're saying, could we just use a beefy VMs in the cloud with 4 cores? So, oh, okay, so use VMware on Azure. Use VMware on Azure? Well, I understand that there's a VMware on Azure as well, and introduction Microsoft Azure VMs for VMware vSphere. Yes, we have those, but obviously the college has to pay for that, right? Any such solution has to be approved by college. I wish we could just switch to it. If they were free, yes, we could just do it. Otherwise, they're more expensive than what we have right now. And we have to then go back to what we were doing in mail server if that also doesn't work. Like do it all within a single VM. Oh, okay, that's what you're saying. We have $100 in our... Oh, okay, so you're saying that install domain controller. Oh, whoa. I think that's my mistake, annotation. So you're saying that just create one virtual machine and make it a domain controller as well as a SQL server, so everything inside, so AD, DC, and DNS. Although now we're at the stage where we have that machine for SQL and we can start doing the SQL specific task, but obviously underlying charges will still apply. Here also the $100 will finish, and also SQL. So that's what you're really saying in this case. We have $100. No, it means running VM on the VM. Yeah. So you mean that I can either use. So this is, you're still talking about Azure, but one big VM or one VM with more memory and CPU. But obviously then we need to have those roles installed in just one machine and just test SQL, right? I guess that's what Paul, you're saying. So that will also run out from with $100. I don't know how we can save $100 with that. But yes, if there are two virtual machines, $100 are being consumed a bit faster. If there's one virtual machine, it's gonna get consumed slower. But they're gonna finish still, because two machines having lesser hardware and one machine having more hardware, still we're consuming hardware at certain rate. So a bit slower it's gonna go, but it's gonna go within lesser time. It will be consumed as well. But anyway, yes, this is another good suggestion. But obviously, we needed a lot of time for testing, and that was not provided as well. Otherwise, we could have saved some more money and bought some more time. Right now, you guys are able to actually create new subscription, another subscription with a new $100. The thing is that moving the machines from one subscription to another, each virtual machine is like 180 GB, 160 GB. As Amir also said here, he tried to download. So downloading those machines and uploading in the new subscription, 180 GB, that is something that I could say that go ahead and do that, but then obviously maybe not everyone will be able to do that or willing to do that. I need to clarify this with the management as well, that how far I can push the students to keep going ahead. So that's why I'm just creating those ease of going ahead, that I could at least show you how it's done, what is what, with hands-on labs, as much as hands-on labs, even if I'm doing from my side. You can follow it, since you have the videos forever, so you can follow it anytime, any next time as well. Okay guys, so the thing is that okay, and then there's Paul says, why can't we RDP into the computers at George Brown? Oh yeah, that's what I was counting on, Paul, that we could RDP into computers in George Brown. That's why I didn't have time to really explore in-depth Azure, as they were saying, don't worry, we will let them connect with VPN, and all of a sudden, kapoosh. 1.5 weeks before, they said no, we don't have it, and I go, what? Okay, then I was forced to use this solution. So why can't we do that? So yeah, it's the whole management that said no. I mean, okay, let me just stop the video then. I don't want to be and back to class. There you go. So let's go ahead and try to come back to the class, and there you are. So here, I mean, they can do it again. Okay, so there's a comment here. I lost all VM machines 2 times and created again. I guess everybody should know how to create everything from the beginning. I mean, yeah. So there's another session that you can create a new subscription with $100 and recreate the whole machines second time here as well. That's another suggestion coming from the student. So guys, I can also push, but I don't think anyone will be able to do that. If you can do that, go ahead. I can help you. Well, you can just follow the videos to create those machines, the new subscription of $100, right? So guys, let's go ahead and let's start both VMs in Azure. I'm just gonna try to go for that. Then since we installed the Ssms here, in first and second VM to test if we can connect to database locally. So we're going to connect from SSMS to our database, or so the SQL Server Management Studio. This is a client with which we connect to our SQL Server, and we can connect from machine 1 and 2. Some of us might not be able to do that because for some we were not able to connect to our well, very few students were not able to connect the second machine to the first machine, or at least the Active Directory was not talking to each other. Although every detail is there in the video, you could just check out what exact steps I took. So once connected, then we can have a brief intro to the features of SQL Server. So we're going to go with the SQL Server features and what our system database is, how do we create a database, then how to install a sample database called AdventureWorks that is created by Microsoft. Also, we'll go for those two disks here as well, as we discussed in mail server, that how to deploy a database with best practices, vendor best practices, that is. Right? So let's go ahead and start our machines first. While those start, then we will go for the slide as well. I'm in my Azure and in the virtual machine area, or suppose you're in the Azure, you can go to portal menu here and then down to the virtual machines area here, and then we will go for your first name VM1 SQL and your first name VM2 SQL. So I'm just gonna go to VM1 SQL. It's opened in the overview and there's a start button here. I'm just gonna click that start, and I'll just go to the your first name VM2 SQL as well and click the start button here. While they are starting, and you can connect from RDP, you can connect from Bastion as well. So hey, did I resume? Yeah, okay. So while they're starting, we can talk about, okay, then sorry, my internet cut out. Can you just see which steps were taken so far? Dylan, we were talking about of if we can have another environment, better environment. Other than that, we just started our virtual machines. So just go ahead and start your virtual machines. Cool. Okay. Let's go ahead and MCSA SQL2016. Well, okay. Why am I reading that? So that's start of the every slide that I'm uploading there. So what we did last time, we created 2 SQL Server machines and installed the infrastructure roles, and then so there we created the resource group. At the end of the course, we're gonna delete this just one resource group, and everything connected to that will be deleted. And also we created the new VNet and subnet, or virtual network and subnet there. Then the virtual machines. So if we, at the end, we created the SSMS there. Ouch. Okay. Well, there goes my subscription. So Yusuf says there goes my subscription. Eric says disabled. Never left it running. And Brady says disabled. Okay. Andrew says disabled. Guys. Oh, Vincent says disabled. So just take a screenshot. Oh, Jericho says, John says, I think everyone says. I think they might be disabled for everyone. Never left it running either. Same Kingsley, Brady, Yusuf. Okay, so I think the $100 are finished, and this means that we can switch to that model where you can take a screenshot of my screen but put your name there. But we have to understand how SQL Server really works. What is how, just like in mail server, how does it really work? So, and the step by step how to configure. You can also, those who can configure in their laptops in VMware Workstation as well. Otherwise, thing is that once you have understood the concepts, and once you have understood the actual hands-on steps there as well. So obviously, anytime you can repeat, because these videos you have subscription forever. And obviously, we need to understand what's going on, what database inside architecture is, and how tables are created, how scripts are made. So those who have laptops can still create those environments that with SQL Server as well. Or if you want, I can just quickly create that environment in the laptop the way we create for mail server, where some of us can follow if you want. So I have just these few solutions here. Really, I wish I had more solutions there, but we have to also cover all the topics, and wherever you can try to understand. Obviously, when you have the steps in front of you, you can try it anytime in your own lab as well. So, what we'll do, so let's connect to SQL Server from our Ssms, either from VM1 or VM2. Also check how to disconnect and connect again. First of all, how to connect to the SQL Server that we installed, right? And then once connected to SQL, then let's explore all the folders there. So we need to understand that what are the folders there and why are they there? What is the functionality of those features that are showing there? And then there's let's add two disks 40 GB each to the second VM, so we could place database and log files. So we're going to do the same thing, the vendor best practice when it comes to creating databases. So just like in mail server, I created two disks there within the VMware workstation. So we can do the same thing here for the databases of SQL Server as well. But the database architecture here is totally different from the database architecture in Exchange Server. And then it should also be rate protected, but in Azure Cloud, we have redundancy features provided by Azure, right? And then let's try to add a new database and then path for the database file on second disk while log files on the separate disk. So this is what we did before as well. I'll just quickly show that in diagram that we have two machines here. In the second machine, we already have one disk available there, and we're going to be adding two more disks here. But these are not for the RAID one. We are just creating those, one for database and one for log files. SQL Server has a database, obviously specifically for SQL Server this is used, but also for the Exchange Server, wherever you hear databases and you have your own virtual machine creation. So suppose it is not SaaS based. So in near future, you will be dealing with this type of databases there, SaaS based, which is that you just have a SQL Server in front of you, and you don't have to worry about how many databases you want to create. You just have to worry about what data you're putting in. How do you want to give access to that data to others? Right now we are in IaaS, infrastructure as a service. There you have to make sure that when you're creating databases, that those databases will have their log files on a separate disk and database itself in a separate disk. Exactly. So IaaS is infrastructure as a service, and SaaS is software as a service, as you said. And a good example of SaaS would be, anyone knows a very good example of SaaS? We're pretty much daily using that. G Suite, exactly. And Office 365, exactly. There you go. So SQL Server, there are other ways to deploy SQL servers as well. In Azure, that is specific to Azure, and that is something that I really want to show you as well later, because we're into the full configuration now of SQL Server. We have done so much hard work there. You get to know a lot of Azure components, how to do that, because that's pretty much in the market now. When you hit the job market and you're given level 3 administrator jobs or level 2, so you will see pretty much Azure, AWS, Google Cloud there instead of on-premises, although on-premises is not going that soon. So yes, SaaS based, where you don't have to worry about the underlying architecture, like do I need to give two disks? Do I need to create that many databases? Microsoft will take care of all of that, and you need to concentrate on what data you want to put in. So other than that, so let's go ahead. What I was saying there for the second machine, we're gonna create this type of design. So I'm just gonna go ahead and I'll quickly put that there. Okay. Okay. So let's go ahead. Now my machines would have been powered on by now. So the first thing is, how do we connect from the client Ssms to our SQL Server? So how do we do that? For that, we need to, I'm just going to go back to the lab here. So there I'm inside the Azure. I need to log in. Well, VM1 SQL is already started. Even if I don't log in, the services are available over the network to the second. The infrastructure services are available over the network, even if you don't log in. But I'll just log in case I need to go to DNS and check it out. So I'm going to click the connect button on VM1 and go for either RDP or Bastion. Now we know what to do. So Bastion normally is connected to the VNet level and not subnets. Well, when we cover Inventor, the Azure course, then you're going to go talk. We're going to talk in depth about the networking side of Azure. So here, use Bastion, and I'm going to go for the user accounts there. The domain admin user account, your first name, admin SQL, and the password here. Yikes. Okay, so I'm logging into my first machine. While it is logging in, I'll just go for the second machine and do the Bastion here as well. And it's on the same view here on the second machine. I'll try to log in obviously from the domain admin account. Now, some of the students have done that mistake. Although when I was creating an account for this machine, the local account for this machine was different from the domain admin account in the first machine. So second machines, many students created the exact same named account, so they were confused in that. So suppose you log in from this domain admin account and you think that you're logging in from domain, you may be logging from local SQL Server. Anyway, I'm just going to click that connect here, and first machine is here, local server, and VM1 SQL. I'll just drag it on the side, and this is second machine. Cost management wise, and I'll just close the rest here. Okay, and okay. So first machine here logged in, and second machine is also logged in. So the first thing is, hey, where's our SQL Server, and how do we connect to that? So we connect with the help of the client called Ssms to the SQL Server. Now our SQL Server is in our, obviously, the second machine. So if I just keep that diagram up so I could explain that what's going on now. These are the two machines here, and server 01 and server 02. So 2, and here not only that we have Active Directory, DNS, and DHCP. I asked you to install SSMS here as well, SQL Server Management Studio, or the client that helps us connect to the SQL Server. And also I asked to install here in case remotely we are not able to connect for some weird reason. If we have our local network, obviously communicating, the two machines are communicating with each other successfully, so SSMS should connect. So, and we have SQL Server instance here, right? So instance. Now I'll call it instance 1. Why? Because I'll show you that you can install in the same machine second instance of SQL Server as well, right? And that we need to know for it's really crucial to know that. Can we install second? No, so suppose you ask that, hey, remember that we installed Exchange Server in server 2. Can we install another instance of Exchange Server in the same machine? No, we cannot. For SCCM, there's another server. For web server, that's another server. We cannot install another instance, but for SQL Server, we can install another instance of that. Otherwise, normally another instance, you just create a new machine, server 3. Another instance, you want a SQL Server, server 4, server 5, so on. But you can install second instance in the same hardware as well. They will just be still considered as, virtually two different SQL servers. Okay, anyway, so this is instance 1 SQL Server. Now, I'm just going to try to connect quickly. First of all, I'll try to so I'm going to open Ssms on both server 1 and server 2, right? Because we have it there both. Normally you can install it on in a production environment. How would you do that? You would have a Windows 10 laptop there, or tablet, maybe a laptop, most probably, obviously. And from there you just install Ssms, right? Because it's just a client that connects you there. So here, so if this machine is pinging the other machine, obviously Ssms can connect to your SQL Server. So let's start first the client on both servers. And first, obviously, locally, I should be able to connect. The client should be able to search for the SQL Server. It's just local. But can we connect from this in our particular network? Technically, yes, you can easily. It's just a client, right? As far as we have the connectivity, yes, it can connect. It should connect. So I'm going to start this Ssms in both servers now. So I'll go back to my server 1 first of all, and where is Ssms? So if I click this Windows icon here, so I can see here Microsoft SQL Server Management Studio. So that this client that helps us connect to our SQL Server is here. So I'm just going to click that to open this. So this is not a SQL Server itself. This is just a client to connect to our SQL Server. So, well, since we installed it in last class, and then after that we're opening it now. So here it is opening. It's thinking of opening, and it's going to take time. So I'm just going to go to the second machine and do the same thing. Just simply open the client there as well. I'm in the second machine, local server, second machine, and here I'll go for that SQL Server Management here. Normally you don't have to install on two machines. You can install on any one machine, and just that's it. Go ahead and connect in a network where you're not expecting any surprises. But just to be on the safe side, if suppose I can't connect from a remote one, so that's why I installed in the local one as well. In VMware environment, I would not have done that. I would have just installed it on a separate server. Okay, so wow, on the first server, it's yeah, now it is open, and it is asking, hey, it's asking the address of the SQL Server. So server type, database engine. Yes, I want to connect to SQL Server's database engine where everything about SQL is available. Second thing is, what is the server name? Oh, actually, I did put that name. Otherwise, if anyone is opening that, you would see it this way, that server name is just empty, and obviously you need to give the server name where the SQL Server was installed. Either you can give just the NetBIOS name or the fully qualified domain name here, and if the connectivity is there, if you can ping, if the NSLOOKUP or the name resolution is working fine, yes, you will connect to that machine where the SQL Server is installed. So this is how it's gonna be when you install Ssms. If I go to the second machine where actually the SQL Server lives, I'm gonna drag this across that Blackboard icon so two machines could be separated, separately, available. No confusion there. So here I'll just also remove that. Well, obviously I had to test first, so that's why it's showing there. That's how it's going to open, and let's just put the machine name where the SQL Server lives. In our obviously we installed SQL Server in the second machine. If I go down here, there is that Ssms link there, yes, but then since SQL Server is installed there, so SQL Server is available here as well, and SQL Server Tools, SQL Server 2016, this is written here, and if you expand down, so you will see all the SQL Server other components, links of other components as well. So it's in only the second machine, obviously. So let's connect to that SQL Server. First, I'm going to connect locally here, which is the easiest one, obviously. It just needs the server name, and it's actually on it right now. In production environment, you normally connect to from a separate one. But in case, suppose separately you're not able to connect, but you are able to RDP into this machine, it's a good thing to install SSMS here as well, in case the remote connection for some reason doesn't work. So I'm going to go to the server manager here and check it out, local server, and all I need is just the FQDN right now to tell the client, hey, there's the SQL server, please connect. So I'm just going to click that server name here, and this is the fully qualified domain name, or I could have just written it as well. Make sure it's the VM2 because that's where the SQL server was installed, and not VM1. So if I copy that, and that's it, cancel, and go back to the SSMS client, here it is asking, and I'll just paste that name here. Now we can connect from our laptop at home if you install in your Windows 10, in your laptop Windows 10 or desktop Windows 10, the SSMS. And if this SQL server is available over the internet, properly published, then you can connect from your laptop SSMS client. You can just install the SSMS client here as well, and you can connect to the SQL server in Azure, which I intend to show you as well. Purely in Azure, how do you install SQL server? There's a very different way to do that. The way we went for is how we install in VMware Workstation or in an on-premises environment. But purely Azure or cloud-based SQL Server, how else it is deployed, I'm going to show you later as well. So right now, I just want to connect with the current credentials here. So that's the domain name here, which it automatically detected because I'm logged in from this, and your first name admin SQL, which is actually my domain, admin account in second machine. So I'm going to click connect here. And well, it's supposed to actually detect, and then yeah. So this is how we can connect to a SQL server, and it then shows all the inside components, all the folders there for a SQL server that we installed. Now this is, I connected from SSMS from that same machine where SQL server is also there, but I need to go to the first machine here. Can I connect from there as well? Obviously, if this machine is over the network having name resolution, there are no issues for name resolution. They can both communicate with each other by name, and they can ping as well, so it should work from here as well. It just needs a correct name of the machine where SQL Server was installed. So I just put it here from server 1, and this is server 1, and I'll connect. So over the network, it should be connecting if the connectivity is there. Yes, it connects from the server 1 as well. So I didn't do anything extra here. It's just that whatever basic communication and connectivity that we carefully configured, because of that, it is able to communicate from server virtual machine 1 to the virtual machine to where the SQL server is there. So in both cases, the SSMS connects. I don't have to connect from both of these, but now I know that if for some reason SSMS here in machine 2 is not working for some reason, I can connect from machine 1 as well, if purely it is just the SSMS issue or the client issue. So in machine 1 it is open, it's okay, we're connected. So this would be our first screenshot with your name in the background, that SQL SSMS connected to SQL Server. So let's take a screenshot here. Let's take a screenshot. I'm just gonna take a sample screenshot here as well. That SSMS connected to SQL Server. SSMS connected to SQL Server. Take a screenshot here. I'll just simply put it on OneNote now. And so it's screenshot 1, SSMS connected to SQL Server. Okay, we didn't take that. I'll take again. Okay, sometimes it gives issues. Really? Okay, I'll go print screen here. And oh, print screen is dangerous. Let me just quickly fix that. Come on, come on. Okay. Oh, it's not just taking screenshot at all. So even my print screen is not. So I'll just put it there in WhatsApp, and later I'll shift it there as well. So it's a SQL Server equals screenshot 1 equals Ssms connected to SQL, and okay, I'm not sure what's going on, but I'm not able to take screenshots, guys. Can anyone put a screenshot there in WhatsApp? You're able to take a screenshot, so anyone can just put a screenshot one there in WhatsApp. I don't know what happened, and it's not saving in my. Okay, I'll go for this one last time, and then let's just go ahead and try to understand more. And oh, serious. Control V is not working at all. Anyway, not good. Nothing. Okay, so hopefully you've taken the screenshots here. There's a screenshot here, and this is screenshot 1. From the video, I can just restart my laptop later in the break or after the class, and I can put all the screenshots there as well. Hopefully you have taken that. But that's the first thing, how to connect. Then second thing is, I'll just be on my second machine, and on second machine, what we see here are databases. So there are databases here. If I expand that, there is system databases, there is database snapshots, and then there is security, server objects, replication, polybase, always on, high availability. Some of the features will not be there, but I will be installing those features there. And then there is management, integration services, catalogs, SQL Server Agent, very important, and then X event profiler. So all the events that are happening in SQL Server are being managed by that. So obviously, SQL Server is all about databases. So here we see that there are system databases and database snapshots, how to create our own database. Then there is a sample database that Microsoft has released for developers, for testers, and it has a lot of tables there, a huge amount of data there that you can play with when you're running queries there. So here, system databases are there, database snapshots are there. Now, first of all, before we go to the database, this is the Ssms from which we're connected to the SQL Server. But suppose I want to disconnect and then connect again. So this is how we disconnect from here. There's a disconnect button here, and it says disconnect. I'm going to click that disconnect, so we are disconnected while Ssms is still open. Now we're no longer connected to the SQL Server. Then there's that connect button, and it pretty much gives you the same screen again. And from there, with this user, you simply click the connect and you connect again. So you can disconnect from here and connect from here. Now, other than this, the databases, there are these databases, and there is a system database. So if we go for, first of all, I can just show you that how to create a database. Then we're going to go inside and check out what are system databases, what is this database snapshots, and then what are the purposes of all these folders here as well. So first of all, if I go for typical creating a new database, so I'm just going to click that database here and then click new database like this. When you right click on databases, there is attach, there is restore database, there is restore files and file groups, and deploy data tier application, import data tier application, start PowerShell, reports, and refresh. So there's that new database. I'm going to click that new database on after right clicking the database itself, and then it shows you certain options there that, hey, okay, your account is this, your server is this, and what is the database name that you want to give here. If you go for your first name SQL, and whatever name you want to give, your first name actually DB01, your first name DB01, right? So this is how we can create a new database. It asks that who's the owner. Yeah, default just means that whichever user has full, first of all, whichever user is logged in and has the full privileges on the SQL Server database is the owner of this new database as well. That's one thing. Second thing, uh, the architecture is still the same for the database inside SQL. Is somewhat same. We can say that it also has its one database file and one log file. Log files always gather all the events, while the database file is where you save all the data. So its initial size is 8 megabyte right now. Obviously there's nothing inside, and then when you put a lot of data inside, then the size increases as well. And the max size it is set to on unlimited, so we can put a limit there as well. Hey, you cannot grow up to more than 80 GB or 100 GB. So we can check it out. We can test it, and then there's by 64 MB it's gonna auto grow. So every 64 MB it's gonna fill up data. When there's that much data, it's gonna just keep filling up the chunks of data inside database. So, and it goes unlimited, but unlimited is obviously not a very good idea in a production environment. So but what are these two lines for? So these are database files, and if I slowly go towards the right side, so there's a path here as well, and that's the default path on the only drive I have here. So this means that we haven't gone for vendor best practice yet, where we can create the two drives, one for database, one for logs separately, and then place the database file on the database drive and the log file on the log file. So if I keep going down here, so this is the path that is showing in the C drive. If I just click this button here, so there is that. Okay, it's just giving me a different path, but it's the same. This is the path which is in the C drive as well. I haven't added the two disks yet, so that's why I cannot change the path yet as well. So I'll just leave the path as the default one. Then there is a file group, and that it says primary and not applicable for log files. So this is just an upcoming topic. But basically what it means is that this is the primary database. You can have its secondary copy database as well. It's not copy, but it's a portion of a database that you can put on a separate drive. So one big database on different hard disks, that is also possible. So when we come to the topic of file group, I'm going to show you then what that means is, and how can you expand one database on multiple drives. One database, not copies. Anyway, so this is how we create a basic excuse me, database here. There are other options here as well, like general and then options here. That's where you can go for general configurations here, like create incremental statistics here is false right now. Create statistics. Auto shrink is false right now. Update statistics. So all these, some features are not changeable, but others are. And these are a lot of features that we're going to later keep on discussing as well. But there is that feature of so we can change that auto grow feature from outside as well. Otherwise that feature normally is here. Right now it's on auto shrink, but the main thing is that we're going to keep it as is for now. So, but these are lots of options that we're going to select, check, and then we're going to understand why these options are there once the database is created. File groups, again, this is what I was saying, that one database can actually span to multiple drives, multiple disks, multiple partitions or volumes. So General, I'll just keep to general here. So the main thing I would have done here was, if I had the two drives, I would have just put the database file in the separate drive and log file in the separate drive. For now, that's it. It's a default database, just to see how to create a basic database. So I'm just gonna press. So what I did was I just put the name there. I didn't make any changes in the options area, and I didn't make changes in the path area, and I'm just pressing OK here. So once I press OK here, the database gets created here. You can create as many databases as your underlying hardware supports. Suppose you have 1 TB disk, then obviously you can create a lot of database, and maybe 512 GB RAM there, and in fact the disk would be also the LANs coming from the SAN and not the local disk, as we discussed in the mail server as well. But I'll show you how to create a SAN storage area network disk by deploying a storage area network software version of that. Okay, so the database is created, and when you expand that, so that new database has database these all folders: tables, views, database diagrams, external resources, synonyms, programmability, service brokers, storage, and security. We're going to explore all those options there, but the main thing you normally are supposed to have is, oh, so there's a question from Paul. What is the difference between the version of MS SQL we are using and the Docker container? So, and there's a link here, hub.docker.com. So the difference is actually not about the SQL Server itself, it's the way you deploy it. I'm just clicking that option here for hub.docker.com. Oh, sorry. Yeah, the container is a service that is available from Microsoft, as well as from uh, Google Cloud, and from AWS as well. They all have their container services. The difference is of deployment and lighter machine, and the isolated environment provided for the application. Now, what did I just said? So containerization, obviously, that is the future where every the virtual machine based applications are going. So suppose you have a virtual machine here, and then you have on this virtual machine. So example would be that you have an OS here in a virtual machine, and then you have a SQL Server here, but you want to also install here, suppose Exchange Server or any other big application, any other application. Some or many of the applications have files. So suppose you deploy the SQL Server here, right? And then you install, try to install some other big application or Exchange Server maybe. So when it's installing, it will say, oh, I have some files here already deployed that are in conflict with what I'm about to deploy here, and my files are in conflict with some files that are already there. When you check, those files belong to another application here. So this means that when you have a big application in one virtual machine, you can't have another application also installed there in majority of the cases. So when it comes to that solution, that boss says, no, I want these two, in fact, three more applications on the same environment here, machine here. So you suppose you take another machine here, and there's an OS here. On top of that, you deploy Docker. Docker is a software that hosts container. That's the specialty of this software called Docker, right? So, and what are containers anyway? So containers are offering isolated environment for every application, has a very small footprint of some we can say remnants of, or very light presence of an OS here, and it has and then it has an application. Then this container can be deployed on Docker in one virtual machine. Then you deploy another container. You can deploy another container that has actually an Exchange server here. Now together they cannot survive, but within containers they can. Some remnants, some very light version of OS files there for to provide binary, and then the third container, and then the fourth container. Those applications that were otherwise not supposed to be installed in the same machine can be installed in a container and provided inside the machine. So since the whole operating system code is not there, the OS itself, so the machine itself is very light, it's easily able to be deployed, and it is, the containers are actually supported every in every platform. So suppose you want to deploy this container on Linux environment, then you want to deploy it on AWS, and then you want to deploy it in Azure, then in cloud. So you can take it anywhere. So isolated application environment, and this in a lighter container. It's in a lighter version of machine is what container offers. Now, what's the difference then? The container is also, yeah, the main thing is that you can deploy lighter, it is called container. Virtual machine is much bigger or much heavier in terms of the OS code there, and it takes more time to start. Containers are lighter and they offer separate application environment. Can we connect SSMS to the container? Yes, we can connect SSMS to the container, but you need to have an application like SQL Server or Exchange Server or any other. The containerized version of that application should be there, and normally Docker has those containerized versions of SQL Server. So it's an already created image by somebody that you simply deploy and connect to. Okay. And is it kind of hypervisor type 2? Well, concept wise we can say, but it's not hypervisor at all. First of all, it is deployed on top of a hypervisor containers. It's not hypervisor. It's not type 2 as well. Type 2 actually is slower, and it installs on top of an OS. This container can be deployed directly on a hypervisor as well with the Docker facility there, and this container can be deployed directly on there's another environment called Kubernetes. You would hear that a lot nowadays. Kubernetes works like Docker as well. You don't need actually a hypervisor. You don't need an OS for the container to be deployed. It just needs a environment with Docker. Either you deploy Docker on top of OS, or you deploy Docker on or you deploy Kubernetes directly on their cloud platform and deploy containers on top of that. So no, it's not a hypervisor at all. Yeah, OpenShift Kubernetes. Okay, so guys, this is okay. So that's an interesting question, because that's where we are all going, and by the time this is the time where Kubernetes and everything is deployed. So the winter courses about Azure and AWS. There I intend to cover container and Kubernetes as well, because we're gonna target the AZ-104 certification at that time. Okay, so let's get back to, but yes, you can have SQL Server, containerized SQL Server you need to grab from here and then deploy it in Azure. Yes, you can do that. I'll just put that quickly here and go ahead. Oh, can I do that? Oh, now it's taking screenshots. Seriously? Okay. I don't know what happened at that time. So I'll just go to that environment, and I can now take a screenshot, because I was not able to take a screenshot. So that was screenshot 1 at that time. Okay, yeah. So screenshot 1 was this. Really, it's still not working. The other one worked. So that's something bizarre going on. Okay, guys, so we now know that how to create a database as well. And inside the database, the most important folder here is the tables. Why? Because all the data will be inside the tables. And when we connected to SQL Server, there was no database. We created a database. Then when we created a new database, obviously it's empty. It's new. So there is a tables container. When we expand that, obviously there is no table as well. So if I right click here and click new, then we can create a table. I'm just going brief here just to go for basics, because we need to understand the whole SQL Server components, and then we will later go down to the table as well. So you can click the table here, and it opens that full environment here, and you can just suppose I go for name here, name column, and tab, and then I go for city and tab. I'm just filling fast here, so province, tab, and country, and tab and number. So we can just create a table like that quickly. what is ncar, what is varchar. We're going to talk in detail about that, but you can put that many characters there. A char just means characters, number of characters there. So if this is a typical table that you can create there with all the columns there, and then right click here to save table, and I can click save table, and then I can just name it anything. Suppose it's the employees, employees Toronto branch, or just employees, whatever, we're gonna name that, and press OK. So a typical table gets created as well, and it starts showing under the folder here. And I'm just going to refresh that here to show that table. So the table database DBO or database object dot employees is created there. And if I expand the table, it itself has so many columns there as well that we will later explore as well. But how to create a database, how to go to the tables and create a table, and then if I right click here, then there is select top 1000 rows, edit top 200 rows. You can go for that. Suppose I go for select top 1000 rows, so it shows then that the table here. So this is the name column, this is the city column, this is the province column, country, number. We haven't put any data here. We're going to be doing a lot of data input there. We're going to go for those select and drop and modify all those queries there. But right now, this is just the basic intro to that. That you can create databases, then you can create tables here, and then what are all those folders? What do they really do? What is the security for, storage for? We're going to talk all about that in detail. So I'm just going to collapse that tables here, and then I'm going to collapse that database here as well. So we get to know, okay, we can connect from Ssms to, so we have connected from Ssms to the SQL Server, then we created a database, then we created a table here. Other than that, obviously there are some default databases already created there in the SQL Server. So we create our own custom database, but what are those default databases for? So if I expand the system databases here, so there are master database, there is model database, there is Msdb, and there is Tempdb. So those are the default databases that we're not supposed to. Well, we should know what they are. Then yes, some of those we can make some slight changes there. Otherwise, we're not supposed to make changes if we don't know what we're doing. So these databases are there by default created. We didn't create them, and why they're there. So system, these are called system databases. We're not supposed to touch them unless we know what we're doing. And then if I expand the master database, so it has all just those folders that a typical database normally has. But what's the purpose of these system databases? For that, let's try to know that too. Then we're going to go for the rest of the configurations there as well. I'll just go to that topic first, and then we're going to visit the other areas and try to configure one by one as all the sections of SQL Server. So system databases, SQL Server includes the following system databases: master database, Msdb database, model database, resource database, which you didn't see. So we can create that as well, but Tempdb database. So and there's that link for that. Well, the slide is uploaded, so you can see the link there as well. And what then master database do, or what are the tasks for the master database? The master database records all the system level information for a SQL Server system. So records all the system level information. This includes instance-wide metadata such as logon accounts. Okay, how many accounts did you create in the SQL Server? Who did you allow to connect? How many user accounts you created? How many service accounts you have created? And then endpoints. What other endpoints or which other machines or which other databases you're connected to? And then there are linked servers. So you have those servers that are in active passive configurations and are exchanging and synchronizing data with your database, and then system configuration settings. So pretty critical database there, master database, that whatever administration level tasks are going on, security tasks are going on for the SQL Server are being recorded by the master database. So in SQL Server, system objects are no longer stored in the master database. Instead, they are stored in the resource database. So now system objects are what we created, tables, databases, security accounts there. So they are just placed in resource database. So this means that it's kind of a schema of databases there that you can check as well. Okay, there's a picture that has been placed. Oh, maybe I received it just now. Maybe somebody has already put that picture. I just successfully connected Ssms to the MS SQL Server Docker container. Hey, there you go. Way to go, man. So, so you deployed the container and image, and then simply Ssms it. So did you do it on your Azure, right? 705, 706, yeah, just now. Okay, Paul, so you did it on your local machine. You deployed Docker on Windows and then simply deployed container. Okay, that's really good. Very good, very good. Well, that would be great if you can, yeah, do all the labs what I'm doing here, and we can confirm actually with container how does it really survive, because containers have a different way to really do day-to-day jobs, but inside whatever you want to do, definitely that's the same as what we're doing here. Okay, so that's really cool. Very good, very good. Now, in SQL Server, system objects are no longer stored in the so we talked about that, and also the master database. Okay. Also, master is the database that records the existence of all other databases and the location of those database files, and records the initialization information for SQL Server. So that's a lot of things that master database has to do, and obviously that's why we're not supposed to mess with those system databases that we refer to. So master database is a database that records the existence of all other databases. So records the existence of all other databases. So we created like one database. Now, suppose you create like 20 more databases there. So all the record of that is in master database as well. And the location of those databases. Suppose you added actually 20 more drives, 20 hard disks there, right? And you've put some databases in some disks, some databases in other disks. So the whole location information will be in the master database as well. You can run some queries and find out that which database is actually on which, what is the folder structure and the path where the database is deployed, on which drive it is deployed. So a master database has all that information, and then records the initialization information of SQL Server. So suppose your SQL Server restarted last night. So obviously, suppose it was restarted for no reason. So master database would have that record as well. Hey, last night at 11 p.m. SQL Server restarted, and you know that you did not initiate that restart yourself. So you would know that information. Okay, why did it restart? Normally, those events are stored in the event viewer, but master database in SQL Server also has a record of initialization information for SQL Server. So what if starting files were needed to start a SQL Server database. So therefore, SQL Server cannot start if the master database is unavailable. So that's the main thing. Since master database pretty much runs the whole show here, so we make sure that master database is never dismounted or corrupted or deleted for some reason, any reason. So we need to make sure that master database is always up and running in SQL Server, and least amount of changes we can do there, the better. So that's about the master database, that it runs all the tasks there. Day-to-day information is stored there. So all the critical tasks are done by a master database. Excuse me. Then there is Msdb database as well, and it is used by SQL Server Agent for scheduling alerts and jobs. Okay, so the scheduling SQL Server Agent. Now, SQL Server Agent is a separate service that we will see in SQL Server, and that SQL Server Agent does the scheduling, alerts, and jobs. So, whatever automated jobs you have, initiated and scheduled. This is MSDB is having that information, and the configuration is done here. So this is a database that is already there in SQL Server. Now, suppose you scheduled maintenance for databases that all the unnecessary data inside a database should be deleted there every on every weekend. This automatically the script would dismount the database and then go for some we call it white spaces. So normally white space is that database area that doesn't have any data, but is still taking space on our hard disks. So normally those white spaces need to be removed from there with the maintenance task there. Also, suppose there's some data input coming from to the database from some application. You create an application, and that application, thousands of users are connecting to that application, and they are modifying or adding data or deleting data. So much is going on. That whole thing is in the background being saved inside your database here. So you would just schedule that whenever that application is nobody's connected at that time. Simply just check out how much data was moved, or whatever is left is also synchronized. Or you can schedule that this DB can synchronize all the data and save it in another DB, which is just a passive copy or standby copy of that DB. So whatever you want to schedule there, you can schedule in when you're doing the scheduling. It is saved in MSDB database here. The MSDB database is used by SQL Server Agent for scheduling alerts and jobs, and by other features such as SQL Server Management Studio, Service Broker, and Database Mail. So database mail obviously would be, you have to configure the database mail to send alerts over the email to you, obviously. So this means that database mail has to be connected to some kind of exchange server here, some kind of messaging application there, and then uh, you know uh, then the email could be sent. So you have to put the SMTP address there, and then any alerts that needs to be, suppose a database is down or dismounted for some reason, or just the space is filling up on the disk of the SQL Server. So all those alerts can be sent through the database mail, through the messaging application that you have in your environment, to your email address, to your mailbox. So not only that it helps you schedule, but also it helps you, MSDB database helps you send the alerts as well. So for that, it is really important. So if I go for this, really, okay, I'll try to put it here. Okay, so I think my clipboard is really strange. Okay, I'll just go back here since we have a video recording as well. Thank God. So the MSDB database, we talked about that, scheduling and alerts. And then, for example, SQL Server automatically maintains a complete online backup and restore history within tables in MSDB. So it's going to save all the information in the tables that it create. That when was the last backup done? So normally, when does the backup happen in any company? During the weekdays, the backups are incremental backups are run during weekdays for the databases and applications, and on the weekend the full backup is run. So incremental backups are always smaller in size, and they only take a backup of the modifications that we have done, and they don't take or they do not copy the whole database again every day. Just whatever modifications were done, they copy that. So the record of, hey, when did the backup really was done will be also saved in the Msdb database there. And then this information includes the name of the party that performed the backup. So suppose you have an application, suppose there's a Veeam, maybe you've heard about that application Veeam that takes backup of all the virtual environment in the cloud as well. So that performed the backup, the time, so whichever application performed it, the name of that, it will store, remember the time of the backup and the devices or files where the backup is stored. So everything about backup will be saved actually in the Msdb database there. SQL Server Management Studio uses this information to propose a plan for restoring a database and applying any transaction log backups. So we talked about the transaction log as well in mail server, but here it clearly says that the backup application Msdb database takes a record of or records the performances of the backup application if it had gotten rid of the committed transaction log files. So the summary of that, which we have talked in mail server, but in terms of the database here, the summary is just that when you have a database here, so all the data is not directly put in the database, they are temporarily put in the transaction log files. So suppose this is a transaction log file, 1 MB transaction log files, 2 MB, 3 MB, 1 MB, each transaction log file is 1 MB. And all the data, instead of being placed directly in the database, is first temporarily placed in the transaction log files, and the transaction log files normally commit the database, or whatever data was stored in the transaction log files, tlog, I'll just put it transaction log or tlog files. So as soon as the data is temporarily placed here, it is copied right away from the first transaction log file to the database. Then the second transaction log file, which is just a 1 MB file, a text file that saves the data temporarily that is supposed to be actually going to the database itself. So it copies the data from here, then the third one, then the fourth one, they all copy and permanently save the data in the database. So whatever application was sending a data, suppose it was a hospital application, and it's people are saving all the information there. So all the patient record there and the operations record there is being saved first inside the transaction log files, and they fill up real fast because they're just 1 MB files there. And then they start saving or copying that data or committing that data to the database as well. So whichever transaction log files have copied the data permanently to the database are not needed anymore, but they are taking up space on the disk. So that's what they're saying here, that the backups, so the Msdb database also keeps a record of the backup application. Backup application's main task is to take a backup of the current changes, but also to delete the those transaction log files which have already copied their data permanently to the database now. So backup software, suppose you actually bought the Veeam software. There are many other, and I don't have shares in this company, so I'm not promoting this as well. Well, it's just famous, that's why I'm saying that. So Veeam software, backup software there. So the backup utility will try to talk to the .chk file here, which is the check file, and that file actually has a record of, hey, which transaction log files have copied or committed its data to the permanently to the database, and which transaction log files have still not yet copied its data permanently to the database. So whichever transaction log files have done that copying of data, their data to the database are not needed. So the Veeam software talks to the check file. Check file says, okay, these guys are already done, you can delete them. So the Veeam backup software or any backup software simply deletes these files, and it does not touch those files which have not yet saved its data permanently in the database. So that's what the main purpose of this Msdb does. Msdb just takes a record of what's going on, and if the backup software really did remove the transaction log files which have committed their data to the SQL Server or not. So you can run some queries against the Msdb database to know that, hey, what happened to the backup task last night? Did it really took a backup because our drives are filling up now? Suppose the backup software had some issue and it did not run last night. So all the transaction log files that have already copied their data permanently to the database are filling up the disk space. And if it's a big company, huge amount of data is being put inside, so those transaction log files get created in hundreds and thousands. So you better have a good space there, disk space there, and that you can survive at least if one night the backup did not work. So your disk will not fill up because of too much data coming into the database. So anyway, this is a fine balance that you just have to keep an eye on the whole process there. If you understand the whole process, obviously you will know what to do. So I'll just try to take a screenshot of this. Otherwise, it is being recorded in the video. So I'll just try to check if I can. Oh, I can't take a screen. So from here, I'll transfer that to the. I'll just try once and. So it is working. Okay, guys. So we understand that what is master database doing, and what is that MSDB database doing, and then there are some more detail of the MSDB database there. That backup events for all databases are recorded even if they were created with custom applications or third-party tools. So the backup events will be recorded. That's what they're saying. We just talked about that. For example, if you use Microsoft Visual Basic application that calls SQL Server Management objects to perform backup operations, the event is logged in the MSDB. Okay, that's the same thing. They're just giving an example. If the backup was done for the SQL Server, MSDB records that. That's the main point here. And then further, to help you protect the information that is stored in MSDB, we recommend that you consider placing the MSDB transaction log on fault tolerant storage. So because it is doing a very sensitive task, obviously this MSDB database, suppose that's the database here. We know that where's the database in our environment. So if I just go to our environment in the second SQL Server, so this is the MSDB database, right? So they're just saying that don't put it on a C drive. You can put it on a highly available storage, fault tolerant storage, right? If I right click here to this MSDB database and go to the properties. Now this is a system database. I'm not supposed to, I should know what I'm doing, and for maintenance tasks we can visit this database there. So if I want to check that, hey, where is it really installed? So if I go to the files area of MSDB database, because Microsoft says that don't put it on the C drive or put it on a fault tolerant storage. Suppose your C volume is actually on RAID 1, you're okay. It's just one disk and it's not on RAID 1 or 5 or 10, then it's recommended to. So it has all the complete, critical data there. So what can be done if we go to MSDB, right click and go to properties and click the files, you can see that it's right now in the C drive here. And we can, if we have extra drives coming from SAN, storage area network, then or LUNs, then we can just transfer this, move this database to the drives that are coming from SAN. Now we talked about, I'm talking about SAN here, but how does it really work? Suppose you have a SAN tower here. That SAN tower or storage area network tower has disk 1, disk 2, disk 3. It's all about disks, right? You have expensive, highly available disks here. Maybe there are 500 disks here, right? And each disk is maybe 250 GB, 512 GB, 1 terabyte each. So whatever you want to spend here. SAN normally is a very expensive solution. It's like $80,000, $100,000, even $500,000 or even more SAN solution with big companies. So what they do is that you can just over the network share the disk on the SQL Server. So SQL Server will have its local disks, and these local disks, other than these, suppose you want 100 disks on the SQL Server, 100 disks on a machine. So physically we can't put actually 100 disks. I heard about 60 disks on a physical server locally you can put. Maybe more are possible, but maybe, okay, suppose you need 200 disks here. So you can't possibly just put physically 200 disks here. So that's why SAN is purchased, where the disks are shared over the network either through fiber optic cables or over the Ethernet iSCSI with current Ethernet network over the Ethernet network, which is slower obviously. But you can share a lot of disks here. When the disks are actually mapped to this machine, and you put the Msdb database, this database, you actually don't put it in C drive, and you put it in this one. Suppose this is E drive, this is F drive, this is G drive, and so on. So when you put that Msdb database here on this disk, so the database is actually living here on the SAN, and this SAN is highly available. There is another tower here that, and whatever you put here, it is being copied here as well. Then it is being backed up here as well. So a lot of security there for. So if this SQL Server goes down, obviously over the SAN storage area network, first of all, the Msdb database was never installed on the local C drive. If the SQL Server goes down, the machine goes down, it was that the database was never there. It was actually on SAN. So the database will be safe if the machine goes down, and you can even access the database from another machine that also has access to the same E drive, F drive. You can share that one drive of SAN with the even 2, 3, 4, 10, 20, 2000 machines. One disk over the SAN can be mapped to even 200 machines, 2000 machines even. So every machine will have the same disk available, so you can access the database from any other machine as well. So that's the main benefit of having your SAN or fault tolerant database. Obviously the local disk would also be RAID protected, RAID 1, 5 or 10 or 6, but RAID 1, 5, RAID 10, RAID 6 also. So these are all redundant, but the SAN would be the best solution. There's another solution called vSAN, which you must have heard in your virtualization class offered by VMware. So that is also very famous, because then you don't need to purchase $100,000 solution, SAN solution. You can go for your local disk based highly available storage as well. Anyway, so this is what they're saying in the slide, that don't put the Msdb on your C drive, put it on either a fault tolerant solution. Now they did not specifically said that it should be SAN, but this is how you must be. Every company does in the production environment, in the companies, in the data centers. They just put simply databases on shared disks. These are also called LUNs, or logical unit numbers, or shared disks, right? Shared disks. Okay, so that's the concept behind the fault tolerance for this particular database. But obviously all these databases should be on shared disks, so if the server goes down, these databases would still be accessible, or at least not damaged because of whatever corruption happened on the server. So I'll try to put it here. Oh, it does copy here, so it should copy here as well. And it does not. Okay. Okay. So, well, it's copied there. Later, I'll just take it from there to here. Oh, now it does. Anyway, weird things going on. Now, if we go for these system databases, so I showed that if you go inside the system database, you can easily move that database, obviously during weekends or when nobody's working on, and move that database to another location as well. Otherwise, normally we don't mess with these, or you know, we must know that what we're doing in order to touch these system databases that are really running the whole SQL Server. If we go back there, so by default Msdb, first they were saying that it should be a fault tolerant storage, and then I explained that you can have SAN there, storage area network, that's the best form of, or vSAN, the best form of fault tolerant storage. Otherwise, just go for local disk if you're going for then RAID 1, RAID 5, RAID 6, RAID 10. You can go for that. By default, Msdb uses the simple recovery model. If you use the backup and restore history tables, we recommend that you use the full recovery model for Msdb. For example, see recovery model SQL Server. Notice that when SQL Server is installed or upgraded, and whenever setup is used to rebuild the system databases, the recovery model of Msdb is automatically set. So what they're saying in English is that you can use the already provided restore, backup and restore solution by SQL Server itself. So not only that outside backup application is backing up your database, but it is also that inside this SQL Server you can back up anything about the Msdb in the tables, and those tables can be saved by the SQL Server, and the SQL Server also offers recovery models or recovering that data, critical data from Msdb for Msdb from those tables as well, which the SQL can also back up separately. That's an internal process there. So outside backup and inside, backup and recovery of the configuration is also very cool configurations there. Plus you have a fault tolerant storage. Plus you have, there's another feature called always on, where you can have a copy of these databases, and if the database goes down, the other one comes up. So other than that, we have model database here. Model database is used as the template for all databases created on the instance of SQL Server. So remember that we created a template machine in our VMware workstation. So a template machine, you can create a copy of that, exact copy of that as well. So in databases also, there is a template database. The model database is actually a template database. Suppose I make some changes to the model database. Then after that, I create a new database. The new database will have exactly those changes that I made in the model database. So model database pretty much is template. You make that change. Any new databases will have those changes as well if you made any changes to the model database. So we have to be very careful about this template or model database, that whatever we're doing, we should be very careful. Any new database will adopt those changes that we have done in model database. Modifications made to the model database, such as database size, collation, recovery model, and other database options are applied to any database created afterward. So obviously what template does, hopefully we understand that already. So whatever changes we make, that will be reflected in the new database that we created. So the model database is used as the template for all databases created on an instance of SQL Server, because Tempdb is created every time SQL Server is started. The model database must always exist on a SQL Server system. So the entire contents of the model database, including database options, are copied to the new databases. Yeah, we get that idea. It's just repeating that again, that the model database will have. Okay, that was 6:30. Oh, now I'm seeing after 1 hour. Yikes. Okay, so I just saw Amir's screenshot. Hopefully you were connected from the local Ssms. Okay, so some of the settings of model are also used for creating a new Tempdb. So we're going to talk about Tempdb, but Tempdb gets created when you start SQL Server. Suppose I shut down SQL Server now, Tempdb will be gone with all the changes that it has saved. When I start the SQL Server, Tempdb will be created again, right? So what does Tempdb do? That's upcoming right now, but whatever tasks and processes going on are temporarily saved in the Tempdb. That's what it does. So, but Tempdb gets created from the template or model database every time when the SQL Server is started. Um, so the model database must always exist on a SQL Server system. Obviously, this is another system database that is very critical. All system databases are critical, right? So how many system databases are there? Master database, model database, Msdb, and Tempdb, right? So we talked about master database, model database, Msdb, and then we need to talk about Tempdb as well. So obviously these four are critical. If I go ahead with this, so newly created user databases use the same recovery model as the model database. The default is user configurable. To learn the current recovery model of the recovery model just offers that, hey, I'm going to make sure that whatever configurational changes you have made, I'm going to save that and I'm going to make it available to you when you need that. So we're going to talk about recovery model and recovery databases as well later. So when a create database statement is issued, the first part of the database is created by copying in the contents of model database. It just repeats the same thing again, that it's a template machine, template database, and any new database is a copy of this model database. Okay, and if there's any other new point, then I'll go for it. If you modify the model database, all databases created afterward will inherit those changes. Okay, yeah, well, that's what we talked about. Suppose you create in model database 2 tables, right? When a new database is created, there is no table, and I showed you how to create a table, right? We're going to go in depth with that later as well. But suppose you actually created 2 tables already in the model database, so obviously any new database will have those tables as well. Again, it's a template, so we get the idea. File properties of the model database are an exception and are ignored except the initial size of the data file. So some of the file properties of the model database are actually not copied to the new one for administrative purposes. But initial size we know that it is 8 MB. We created a new database, right? And the initial size for that was 8 MB here, right? So when we were creating, we knew that size there. If I right click here and go to properties, I think it will show here. So number of users 4, and yes, space available is 5 MB. Size is actually 16 MB. Okay, so while it was getting created, so it was shown as 8, but basically it's 16 MB right now after creation. Well, still very small. So you can just create that initial size. Hey, make a 1 terabyte database initially. So yeah, that would be not very wise to do, but you can just put a size there as well, that hey, I want this, any new database should be created with this much size. The default initial size of the model database and data and log file is 8 MB. Inside it's just showing 16 MB right now. Then comes the resource database, and it's a read-only database that contains system objects that are included with SQL Server. System objects are physically persisted in the resource database, but they logically appear in the system schema of every database. So first of all, it's a read-only database, and it contains system objects that are included with SQL Server. So these are all administrative related components that are in the resource database. Obviously, the first thing would be from the system databases, which is the most critical one. It also says that all the system objects are for the master database are actually stored in the resource database, which means that and what does master database do? It records all the system level information, whatever configuration you have done for the SQL Server is stored in master database. Whatever user accounts, so all really critical information, so it's all stored. Master database controls them, but stores it in resource database. So that's what they're saying here. So if I go down to the resource database, is a read-only database that contains system. Yeah, we talked about that. The resource database is a read-only database that contains all the system objects that are included with SQL Server. Seriously, both lines saying something. SQL Server system objects such as sys.objects are physically persisted in the resource database, but they logically appear in the sys schema of every database. So the resource database does not contain user data or user metadata. So the main thing here to understand is that resource database is read-only. We can't make changes here. Second thing, all the configurational information, maybe security user account information, not maybe, it is user account information, are all stored in resource database. So then ID here. Okay, yeah, Kingsley. I don't know what you mean by that. So yeah, today's too much. Well, without that critical theory, how can we go ahead? So I had to explain all that. Otherwise, there are labs there as well. In early versions of SQL Server, upgrading required dropping and creating system objects because the resource database file contains all system objects. So the thing is that any critical configuration is saved in resource database, and it is retrieved from there as well. But we cannot really make changes ourselves into the resource database. So then there is final, and that is Tempdb here. So Tempdb is a workspace for holding temporary objects or intermediate result sets. So what happens is when you start SQL Server and you're really working on the database is there. Suppose the database is connected to some application here. So that application is putting a lot of data inside. So there's a lot of activity going on. Data is being created, it's being deleted, it's being modified here. So some end users are connected, some applications are connected. There are some connectivity or connectors here that are maybe connecting, then disconnecting, then connecting. So all the current activity, real-time activity that is going on is saved in temp database there. So suppose the application is stopped, all employees went back home, the application is just idle. So after some 30 minutes of idle time, suppose you put a policy there, hey, disconnect the application if it is idle for 30 minutes, and then when somebody uses it, then make a connection. So the main thing is that Tempdb stores all the activity that is going on temporarily. Suppose you shut down the SQL Server, whatever was stored in Tempdb is gone, deleted. When you start the SQL Server again, then whenever you start any activity, it will be stored temporarily in the Tempdb, hence the name Tempdb. So no, Kingsley, for that comment there will be -10 temperature outside. Okay, I'm just kidding. So here, the Tempdb system database is a global resource that's available to all users connected to the instance. So again, it's just saying that it's a global resource for all the users connected. Whatever they're doing is being temporarily saved in the Tempdb. Temporary user objects that are explicitly created. They include global or local temporary tables and indexes, temporary stored procedures, table variables, tables returned in table value. So pretty much whatever task you're going for, whatever scripts you're running there, stored procedure is just combination of 3 or 4 tasks that you have automated with the help of stored procedure. So whatever you're running is temporarily being saved on the temp database. Well, there are some scripts there as well. We're gonna use those later as well. Right now, so internal objects that the database engine creates, they include work tables, work files. So work tables where you're right now putting data, and then work files, and then intermediate sort results. Suppose you're searching something there. Normally in databases, obviously, suppose it's a library, it's a hospital, search is the thing that goes on the most. That activity happens in large scale in databases. So those search results are temporarily saved in Tempdb as well. Suppose you want to retrieve them. And to run them fast. Version stores are stored in Tempdb, which are collections of data pages that hold the data rows that support features for row versioning. So anyway, any data that has a second version of that, any table whose second version is there, so this is also stored. Row versions, then row versions again is written there, that are generated by data modification and that are generated by data modification transactions for features. So we're going to talk about all this new terminology that we are seeing there as well. But otherwise, this is all about the Tempdb, that whatever real-time activities going on is happening in with Tempdb there. So, okay guys, just a sec. Okay, guys. So there's that. Oh, yeah. I had to just give something there. Oh, okay. Was the firewall? Cool. So what we were talking about is the Tempdb is just temporary storing, and it's just giving all the details here. When you go a bit more in depth, you will understand then what it's talking about. Right now, there's a lot of new terminology that is also. It's talking about operations with Tempdb are minimally logged so that transactions can be rolled back. Now, this is also important that whatever is happening in the Tempdb is minimally logged. So a lot of log files with a lot of records of what's going on with the timestamp are not created. Log files a lot are not created for Tempdb, and they are rolled back as well easily because it's all temporary data that is supposed to be created here. Tempdb is recreated every time SQL Server is started, so that the system always starts with a clean copy of the database. That is also, so suppose in the midterm quiz I say that Tempdb is never recreated and it is just permanently once created and never recreated, so that will be false. It would be that Tempdb is recreated every time SQL Server is started. So your midterm quiz will have obviously questions from all these, and it will be true false or multiple choice, mostly true false, and it will be open book as well, but I'll put some challenge there as well. Okay, so temporary tables and stored procedures are dropped automatically on disconnect, and no connections are active when the system is shut down. So obviously when the system shuts down, everything about Tempdb is unavailable or shuts down as well. So Tempdb never has anything to be saved from one session of SQL Server to another. So yeah, it does not save anything. Everything is deleted actually after shutdown. As soon as shutdown happens, everything is deleted in Tempdb, gone. And when it restarts, it's a totally new copy of the Tempdb or temporary database. Backup and restore procedures operations are not allowed on, so you cannot actually back up the Tempdb. So suppose in midterm I say that we can easily back up system databases including Tempdb, so it will be false, right? So you cannot back up Tempdb. It's temporary. That's why then putting all the resources on the Tempdb there. Guys, so let's so there are so many tasks that we need to do in terms of the lab tasks. So we're gonna do that after the break. I think I've bombarded you with too much theory here, but we have a lot of configurations to do and understand as well. So let's take that break and then come back. So week class, so it's 7:50. So class starts at 8:10. Let's take a break and then class starts at 8:10. So I'll minimize this. Okay, let's go for the rest of the tasks as well, and lots of screenshots will be coming this and for the tasks. Let's connect to SQL Server from our Ssms, either from VM1 or VM2 done. Once connected to SQL Server, explore the folders. We need to do that, but we need to also go for adding 2 disks to the Azure virtual machine, second one, and then format them and then create empty folders inside the 2 disks. One is database and other is logs, just like in mail server. Any database you have to do that, or it's the vendor best practice. And we don't need to RAID protect them because underlying Azure disk and data protection is already there. Normally Azure copies that data to their other data centers as well. So if there's a data center level failure on the Azure side, on another data center, your data will be still there. And let's try to add a new database. Then yeah, so we did that. First, we're going to create the 2 disks. So I'm just gonna quickly put that there. What we're gonna do is we'll go for the 1 disk is already there, but we're gonna be adding 2 more disks. We can just add 50 GB or 60 GB disks we can add, and then we're going to name them with the database and logs. So and then once those are added to the server 2 in Azure second virtual machine, then we're gonna have to format them. So obviously once 2 disks are added, then we do the following: bring online, initialize, and then format both. And obviously label them as database and logs. So let's do that. Once this is done, then we can go for create a new database. Where its database file will be in database disk and log file will be in logs disk. So okay. Also, when we go for label them as database and logs file and logs, we must remember to create an empty folder in each disk called database and logs, right? Okay, so first step, I'm going to go to the second server 2, and I'm going to add 2 disks there. So I'll just go back to the Azure environment, and there's one database already created there that is created on the C drive, but now we're going to add the 2 disks to follow the vendor best practice. So I'm going to go to the Azure Azure dashboard here, and here on the second machine I'll be adding 2 disks now. So on the second machine I'll be adding 2 disks. So I'll select the second machine and then click the disks here. this one. So once we click the disks, then you can see that already there is one disk that is by default created, and that's a C drive where the operating system is placed. But I'm going to be adding two more disks here, so that's create and attach a new disk here. It says, so I'm just going to click that, create and attach a new disk. So that's launch 0. It starts with logical unit number or a disk over the network. It is this, and then it has a size of 4 GB, so I'll just put it 60 GB. We need to name it as well, so we can name it database, and it's a premium SSD, so it's gonna perform good. Otherwise, we can also have a standard SSD and standard HDD as well. So that's premium would be for, normally the premium is actually used for the SQL databases where SQL are heavily used, so the performance would be good. But here we're not gonna heavily use, obviously. And if you go to the right side here, then do you want, so it's going to be encrypted, and also host caching. So do you want to make it a read-only drive or a read and write? So whatever data is there cannot be changed later. So I'll just make it as read-write configuration for this drive. So the changes here are that read-write configuration, and then there is launch 0. Its the name is database and 60 GB size. So that's what I configured. Now the machine is already started. I didn't shut it down. So can I add a disk while the machine is still started? And is the operating system inside the machine going to detect that? So I'm just going to click save here. And so it is saved, and the disk seems to be successfully added, but I need to go ahead to the machine and confirm that. So how do I confirm that? I'm going to minimize this Ssms and go down to this server manager. Well, it's already the server manager is open, so I'll go up to the tools here, and I need to just click that computer management. I need to just check that if the disk is detected by the disk management of the second machine. So I'll click the computer management here, and then the disk management. Yeah, it detects the second disk. It detects the disk that I've added, and it says that, hey, do you want me to initialize? So yes, I want to initialize this disk, and I'll just simply, so either MBR or GPT, doesn't really matter. MBR supports up to only 2 terabyte, but our disk is not reaching that size, so anyone is okay. So I'm just going to press OK here to initialize this disk. But I need actually 2 disks, so I'll just go back to the console, and just in the second virtual machine, then in the disks area of the second virtual machine, I'm going to go for create and attach a new disk. So that's the lawn 1 now, logical unit number 1. The disk name would be logs, and this size here also I'll give 60. It's also premium SSD, although we don't need premium speed there. And if I go further down here, so this is read write as well, so I want to read write, make changes there. So that's the second disk, and I'm going to click save here as well, after checking that the first disk was detected by the operating system while the machine is started. And the second disk, well, it's still going on here, but I can so update it. Okay, so it's done. So guys, that would be our second screenshot here, that the 2 disks added to second machine. 2 disks added to second machine. So take a screenshot here, take a screenshot here, take a screenshot here. 2 disks added to, and make sure your name is showing in the background. And 2 disks added to the second virtual machine. I'll just take a screenshot now. So screenshot 2, 2 disks, screenshot 2 disks added to second VM. Okay, I hope it gets copied there as well. So it's SQL Server equals screenshot 2 2 disks added to second VM. Oh, wait, actually, it's okay now. So that's the second screenshot, and hopefully you've taken that. And so the 2 disks have been added. I'm just gonna quickly go ahead and try to I'll format them and then create one folder.
Excuse me, is this the second screenshot?
Yeah, that's the second screenshot.
1 second, please.
Okay, so hopefully you've taken a screenshot. Let's go ahead. And so that's the database, that's the logs disk, but that's the outside name for that. I'll go to the machine and simply format the 2 disks and then create empty folder of database and logs in each. So I'll go for the second disk here, to the second virtual machine now. And in the second virtual machine, this computer management is still open. And if I refresh this, there's no refresh button. Yeah, refresh is there. So it does detect the second disk as well now. So the disk 2 and disk 3 in my case are detected. I'm just gonna make it full screen here, and then go for this, scroll down. So the 2 disks are showing here. So I'm just gonna initialize the second disk as well by right clicking on the, well, it's overall it's the third disk, but the second that I added, initialize, and just press OK to GPT or MBR, whichever. So I'm just gonna format the 2 disks one by one. So I'll go for the first newly added disk, new simple volume, just like we did in VMware Workstation and for the mail server. I'm gonna click next here. It's the whole size is okay, 60 GB. Next, it's catching the E drive letter, and then next. So that's the label exchange. Oh, did I put exchange? Seriously, database, and perform a quick format. I'll click next here and finish. So the formatting for the first disk is going on. So I'm going to go for the second disk and go for new simple volume and click next. So we know the drill now. Next, F drive, yes. Next, just the label is logs, and next, and finish. So it's formatting right now, and it's done. So I'll check here in the file explorer of the second virtual machine that the 2 disks are showing here. So if I go to this PC, and the 2 disks are showing here. So now I'll go inside the database disk, which is empty. I'll create a folder called, oops, not shortcut, but folder. Right click and new folder as database. This is an empty folder database in which I intend to save the database file of the newly created SQL database. In mail server we did that, but I kept the folder structure intact there. Here I have to actually use this, and you will see why. So I'm going to go for the logs file here and right click and click new here for folder, and then I'll put here logs. So each drive has one empty folder. So if we go back to the plan here, then we're done with this whole stuff. Bring online, initialize, format both, label them, create empty folders. Still here it's done. So now what I can do is I can create a new database here where the database files will be in these separate disks. So I'll just go back here and minimize this folder. Okay, the two disks created was the first thing. Second thing is that I'll click this PC and the two disks are, so guys, that would be the third screenshot. The two disks formatted. Third screenshot, two disks formatted. Take a screenshot here. So I'll just quickly take a screenshot here. Two disks formatted in second VM. We can also say that two disks formatted in second VM. So take a screenshot here. Screenshot 3, two disks formatted in second VM. Really? Okay. I think the clipboard is having a bad day today. Okay, right. Okay, so I'm not able to take a screenshot here, seriously, but I'll later take a screenshot when it allows me. I don't know why it's not allowing me. So here, hopefully you were able to take that screenshot 3. So I'll just
So is this a screenshot 3?
I'll put it there. Do this edit. So this is not this one. This is screenshot 3. Two disks added to second VM. The title is there. So take a screenshot here, guys. Take a screenshot here and upload it. Okay, so this is the third screenshot. I'll try to take it again once more, and hopefully it works. Really weird. Really weird. That's the title. Wow. Okay, let's go ahead and, well, it's in the video as well, and if you were, if you're listening, then hopefully you have the screenshot there. I'm not able to take that, but you should be having those screenshots. Okay, so I'm just going to go to that Ssms here, SQL Server Management Studio. I'll create one more database now. So first of all, I'm not messing with the system databases, so I'm just going to collapse that system database folder. Then I'll go to the databases up here and right click here to click new database. And in new database, I'll just stick to the naming convention there, your first name db02, but this time it's the path needs to be changed. And how can we change that? So we will go slightly, I will go slightly to the right side. Now this is going to be our fourth screenshot, where when I'm done with changing the path, at that time I will ask to take a screenshot, not now. So this is the default path, but I need to change that now for the SQL database that I'm creating. So I'll go to the last, the first file is for database and the second is for log files, right? So I'll just go for the first file here, and I'll simply go for the drive E here, which has the database folder. I'll select the database and press OK. So this is the whole folder structure that I am giving to the newly created database. So I've given that. I'm going to show you, but I need to change the second line, which is for log files. I'm going to choose that and give it that second drive path, and in F drive I've created the logs folder, and I'll press OK. So here it is. E drive is a database, and in the database folder, the database file is in the database folder, and the log file for this database is in the logs folder. So that would be our fourth screenshot here. The database files properly placed. We can say database files properly placed. So fourth screenshot here. Take a screenshot here. I'll try to first copy the screenshot series. Okay. Amazing. So take a screenshot here, guys, and I'll put that screenshot 4. So this is the area. So even in the video, you will see that I'm saying that take a screenshot here. So hopefully in your document, you will have that screenshot. So I'll put that title here, SQL Server 4, SQL Server 4 equals the database file properly placed. Database files properly placed. So I've just put that title there for SQL Server screenshot 4 equals screenshot 4. So the title is in WhatsApp. I'll just put that title. So hopefully you've taken the screenshot here right now, everyone, and I'll just place it here. I need to well, I'm saying now where to take the screenshot, but I'll try to put those sample screenshots there. But well, since I'm telling, so obviously you should be able to take the screenshot whether I'm able to provide the sample ones or not, because it's you're here, so you're supposed to take those screenshots, right? So that's screenshot 3 where I asked, and then now screenshot 4 where I asked as well. Okay. And okay. So I'll just try one more time. Nope, not happening. Okay, so once hopefully you've taken the screenshot, guys, then I'm just gonna press OK here, and so the database now is created on the 2 different drives as well, and I'll go check those empty folders if they are populated now. So I'm just going to go ahead and go to the database in the E drive, and then check that yes, there's that database file created. If I go to view of that and click file name extensions, then you can see that there's a .mdf file. So remember that in mail server, when you create a database, it is .edb, the database file name, and here it is .mdf for the SQL Server database. If I go to the F drive, and in the logs I check that, so this is .ldf extension, and that is the logs file that we have created. Actually, it's a logs database. It calls it a database transaction log file. So it's a log file. So this is placed on both areas here, both folders here. I'm going to create two more databases now. This is, let's try to add a new. So add, we can say 3 new databases, and then path of the databases, database files on second disk, while log files on separate third disk, right? So one database got created this way, and I'll go ahead and check the other databases as well. And so your first name db02, then I'll just go for the 3 databases. These 3 databases are actually created with the vendor best practices, right? So I'm going to click the new database again, and here your first name db03, and so this is log files, and this is database file, and it's the primary file group or the main file here. That's the .mdf. So I'm just gonna go down there and change the first folder, as we now know what we need to do. So I'll go back to E drive and give the path of the database folder in E drive, and so this is the db03 being created, and then I'll go for F drive and give the path of logs here. So this is how we can create. So the path now appears like this, right? And so that's all. I'm just gonna press OK here to create the second, and then I'll go for the third database as well. I'll click new, and then your first name db04, and yeah, simply what I did before. So first file path is an E drive database, OK, and second file path F drive logs. There's a recycle bin folder there, but it's a hidden folder. Normally in drives it gets created. Okay, so the path for this is also showing the exact same, but it's database 4 now. So once that is created, I'm just gonna press OK. So the 3 databases now have been created with the vendor best practices there. And if I check the db04 here and properties, and go to files, so yes, it is exactly this path. So existing database, you can see that too always, and I'll click cancel here. If I go to the file explorer here, the yellow folder, now there should be total 3 databases and 3 log files. So the 3 databases .mdf files are created, and obviously the log files are also created. So that would be here, and I'll just try to make 2 windows out of that. So in one screenshot we can have both oh, whatever. Okay. One screenshot we can have both the files showing there. So this is database and .mdf database in SQL, and that's .ldf logs file. So guys, that would be screenshot 5. That database is created with vendor best practice. Take a screenshot here. Screenshot 5, database is created with vendor best practice. So I'll put that title there for screenshot 5. So SQL Server equals screenshot 5 equals databases created with vendor best practice. Okay. So that's the title I put in WhatsApp as well, and take a screenshot here. Take a screenshot here. Hopefully everyone has taken a screenshot with your name in the background showing. So here I'll just put that. Well, why am I always going down there? So that would be our screenshot 5 now. Oh. Okay, that's 20. This is okay, so hopefully you've taken the screenshot 5 as well, and it's this screen. So let's go ahead with the next tasks there. So once it is the databases are created inside, and hopefully we've taken the 5 screenshots, I'm going to close that and this. So the tasks, if we go ahead with the tasks here, let's try to add 3 new databases. Done. Then the tasks still continue here, adding adventureworks.bak sample database. Let's try to install reporting services, and then there is actually the second instance to the same SQL machine that needs to be done as well. So before we go ahead with that, if we are, well, we had talked about the system databases there and their critical tasks that they do. Other than that, there are database snapshots. That folder is there, and obviously it takes all the snapshots there for all the databases, or any snapshot that will be taken will be actually saved here. Is there any snapshot folder here, or do we have to go for the query? If I go to the tasks here, so there are huge amount of tasks there. The stretch, empty columns, data discovery, shrink, backup, restore, mirror. Even you can still do mirroring of a database, right? And then there is database upgrade as well down here, copy database, export, import files. So all those features are there, and generate scripts as well. Mirroring and mirror monitoring is showing there, and shrink and stretch are also showing, right? But then there is Start PowerShell, Azure Data Studio. So normally what happens is that we can just give a query to create a snapshot there. But if I have, maybe I'm missing there, but the snapshot option is actually not there. I'm just going to check one more time. Yeah. So this means normally we go for queries and do that. So when we indulge into a lot of querying, then you will see that how queries are really executed. But right now we're just discovering the whole architecture and all the features there. But the database snapshots, when you run a query, those snapshots are saved here. And why the snapshots? What is the purpose of a snapshot? Because then you can go back to a previous state of the database real quick, and it's really a big time saver. Suppose your database is corrupt, then you can go back to the previous snapshot. Then there is the database folders are there. If I just collapse that, so the databases are showing, and this is inside this databases folder. And we were just looking at this view. Then there is security there as well, and in the security normally we see here logins and server roles, credentials, cryptographic providers, audits, and server audit specifications. So normally logins is where your usernames or user accounts are connected. Either you've created, you can create here local SQL Server local accounts. Some of the default service accounts are there already, but also you can add from Windows Active Directory user accounts into SQL Server. it's already added here, the domain name / my username. So obviously this means that this SQL Server is connected to Active Directory. Not only that, but any other Active Directory user account I also can add here, and then give the permissions to that account, that what kind of permissions are there. If I right click here on this account and go to properties, so this account obviously is the top account or the domain admin account of our Active Directory, but we also in the security and then in the logins area, you can add more local Windows account or Active Directory accounts as well. But if you go to the server roles, so first is the general here for the account, but when you go to the server roles, so this is showing sysadmin membership, and this is the highest membership there. Anyone having the sysadmin server role can do anything on this SQL server. So that's why. And then all the other, we're going to be talking about that, but right now I just want to show that this login account is for that purpose. It's the top admin on this SQL server as well, because it has the membership called sysadmin here, right? So I'm going to cancel that, and you can add the local Windows account there. We're going to have separate class for, obviously, we're going to discuss in depth the logins, how can we create logins, how the local SQL Server login work, and how other logins work. So if you go for that, then there are server roles, and server roles normally are obviously, suppose you have a junior admin there, and junior admin just needs to create databases but nothing else. So you can just add that junior admin to the DB creator role only, and don't give any other role to that person. So if you want to go granular on the permissions, then you come to server roles overall. And credentials, you then again talk that what kind of credentials you really want to use from Windows or from SQL Server. So you can save those credentials here in this. So, and the cryptographic provider, again, you would have encrypted credentials there, credentials with more security, with certificates that you add there, security certificates. So then you can add that information there, cryptographic provider. And audits, obviously for all the audit reports, you want to start auditing on somebody, say, hey, this user logged in at what time, for how long, and what changes did that user made in the database. So all that auditing report can be collected here if enabled, that it's not working by default. And server audit specification, so separately we're going to work on that audit as well. Then there are server objects there, where you have backup devices, endpoints, linked servers, triggers. So all the major tasks of or connections of the servers of this particular SQL server to any other SQL server or to any other application are placed here. Replication, when we go for, so that's a really crucial feature. There's a local publications and a local subscription, so that's a separate lab that we're going to do. But the main purpose of replication is that you can just obviously create one database, is this one, suppose DB01, that's one database, and then you have another SQL Server database there, but that SQL Server database should be, so this is DB01, and this is DB01 copy, right? So you can have this created and synchronized. Obviously it should be in the second SQL Server. So this is the database, right? So it should be in a second SQL Server machine, and this should be in the first SQL machine there. So SQL 1 and SQL 2, and so SQL 1 and SQL 2, right? Talking to this guy. Okay. Anyway, the main thing is that you can use the replication, and we're going to do the whole lab. Now that's why I want that second instance to be installed there, if in case I could not go for a second SQL Server, although I'm going to push for that to show you the whole replication process, and always on. For that we actually need that. So I'll try to go ahead and install the second SQL Server in the background while I'm working on the first one here. but the replication is that it's working that way, that you can have an exact copy on the other side as well. Other than that, hopefully it copies. Oh, so sometimes it's working, sometimes it's not working, or after some time it's working. The copy pasting. Okay, and there's polybase here. Obviously, that polybase feature has to be installed. That's why it's giving this error. And I also need to show you that how to install a feature that has not been installed during the first or initial deployment of the database. If that feature or any feature was missed, then how can you install that feature once that SQL Server is already deployed? So we're going to do that too. But the polybase for that, there is some explanations there as well in the database in the SQL our services, integration services, and well, that's for analytical purposes, but I wanted to just give you the definition there: server and data quality and connectivity reports. Okay, so this means I think it's in the next slide, our upcoming slide, and I started discussing it now. So I can just quickly put it there: SQL2016 polybase, but normally it is for analytical purposes. So what is polybase in polybase features and limitations? So oh, that's a 2018 article. I'll go for. So polybase enables your SQL Server instance to process transact SQL queries that read data from external data sources. SQL Server 2016 and higher can access external data in Hadoop and Azure Blob Storage. So first of all, polybase enables your SQL Server instance to process transact SQL queries. So when you write some scripts or queries there, then it helps you read data from external data sources. So the main thing is it will let you read data from external sources, and that could be a Hadoop database, a big database there for companies that they deploy there, as well as Azure Blob Storage, which is just a storage folder where you can upload files and folders. So it's a container, not container. That's another terminology. But blob storage is just a folder created in Azure where you can upload lots of files and folders there. So starting in SQL 2019, you can now use polybase to access external data in SQL Server, Oracle, even Teradata and MongoDB. Uh, so Paul says, is Azure Blob Storage equivalent to S3 on AWS? Yes, exactly. It is. So blob storage has two types: block blob and page blob. Block blob is for just uploading files and folders. Page blob is for uploading virtual disks that will run actually with virtual machines. So yeah, like S3. Okay, so 2016 does not support this SQL Server, Oracle, Teradata, but 2019 SQL Server actually supports uh, that through Polybase you can make external connections to different sources. But for now, they're just giving an example of Hadoop and Azure Blob Storage. Obviously, this means that there are limitations there, but 2019 SQL Server can connect to all these other very common external data sources. So the same queries that access external data can also target relational data tables in your SQL Server instance. This allows you to combine data from external sources with high value relational data in your database. So the thing is that you would go for polybase when you are connecting the external sources. Not only that you can connect to external sources and retrieve data from there, but also you can reach out to internal data, internal database tables, and also while you're connecting to outside data source. So you can just have two streams of data being used there. So I'll just put that URL in the slide. I'll have to re-upload this slide with the changes there. So I'll just put that here, polybase. Okay, so we understand that, but obviously later we're gonna try to go in depth once we cover all the other critical features. So there's replication, then there is polybase, and then there's always on. Now that's very critical feature, and obviously it's not installed right now. It has to be enabled first, and then you can just configure it. But Windows Server 2016. So if I just type here Windows Server 2016 SQL and then always on, that's one of the main features of high availability for SQL Server, and that's something that obviously every SQL Server DBA, so database administrator, would want to know. Their always on availability groups is an enterprise level high availability and disaster recovery solution introduced in SQL 2012 to enable you to. So that's 2016 they're talking about, but since 2012 they have introduced it. Introduced in SQL 2012 to enable you to maximize availability for one or more user databases. Always on availability groups requires that the SQL Server instances reside on Windows Server failover clustering nodes. So it depends on the failover clustering node, and then you can just really manage that. So now, that's very strange, and it's very nice and strange that Microsoft has actually a full step-by-step lab on configuring the always on feature with screenshots. So that's really amazing to implement that, because if you are applying in any company, and every company has a database, it's not like companies may have database, they have databases. Well, this is SQL, Microsoft SQL, but they have databases, it could be some other. So you must know all the high availability features related to the database. So I'll just put that information here. This is just one step-by-step lab for, but this is always also for Windows Server SQL Server 2016 always on. So by Microsoft, I mean that's it's not that common that Microsoft normally puts. It's such a critical feature that they actually worked hard on that. So I have configured that in the local machines of for the students as well, and it was not that easy. It was just a few million steps, but also my snipping tool glitching. Hey, so it's not just me. Okay, my snipping tool is also really. Oh man, I didn't use the snipping tool. Seriously. Yeah, I tried print screen, and then I tried others, but I didn't try this. Okay. Anyway, thank you for reminding me. I'll cancel that and minimize it. But you wanted me to go back to what? Call it the which one? See, this is not a screenshot that I asked right now. I was just talking about discussing. Screenshot 5 was databases created with vendor best practice. So that screenshot hopefully we have taken already. But right now I didn't ask for any screenshot. Okay. So Amir says, doesn't almost all the companies migrate to cloud-based databases that take care of all configurations? Not all companies, and always on is no. Many of the companies are still going for hybrid scenario, where they have some of the many of the databases are in the cloud, and many of the databases are here in on-premises as well. Why that is the case, and it will remain that way for some years to come. The main problem is that cloud can have an outage, right? So not only that the cloud can have an outage, but also your internet connection can have some. So you have redundant internet connection, maybe two internet connections there, and both may have an issue. So the thing is that if they fully go to cloud, obviously, then they are totally dependent on those guys. Second thing is they normally keep a copy of their critical data here on premises as well while on the cloud. So this is what I'm talking about. Medium to large size companies, they would go hybrid. Many companies did go for full cloud, but the majority are staying hybrid. Some of the data always remains in their own data center, and maybe 50-50 or 20-80, 80% data up in the cloud, 20% will remain there. So you will always see hybrid environment there. And yeah, so this is something that will remain for quite some time. But yes, ultimately, when all companies have full confidence on cloud, then they will go 100% on cloud. They don't want to go for lose their critical data. They have very good security mechanisms of their own. So yeah, you will see in next 5-6 years at least that hybrid environment is still being used. So always on replication, all these features need to be known. Also, those who have gone fully on the cloud, you still need to have, if they are not offering that SaaS based model. Suppose you go for SaaS based model, then yes, totally they are responsible for everything. But if you go for IaaC, and right now currently it's infrastructure as a service and not software as a service, it's not IaaS. So in that case, you have to enable replication services yourself, and you have to enable always on yourself. And also, while underlying high availability is there, database high availability is your responsibility. So if you're using this model, then these features are still critical, even in purely in the cloud. Okay, then we go ahead and yeah, we were talking about the always on features there, and Microsoft has given an excellent lab here that you should see, and before going to an interview, just once visit this screen. It's an official Microsoft lab there. I'm going to go to images there just to give an idea about the structure of there are so many sites that have discussed this. So there's a primary replica here. So if I just go to that some site there that have discussed the always on. Now this is production site, or this is in one of the banks, well, in Scotiabank, we had a production site in downtown Toronto, and the DR site was in Etobicoke data centers. So this is production site. So this is one branch, and this is the disaster recovery site or the other branch. So always on availability groups is configured within the branch, production branch here, where all the users are connected, and then it is also in the disaster. So disaster recovery site has to be an exact replica of the production site. So primary replica would be where all the end users are connecting, and the secondary replica would be still in the same branch as well, while then exactly that primary replica and secondary replica will be in the disaster recovery side as well. So obviously, first of all, the local high availability is provided. And you can see that there's a one storage that has just database, other storage that has just log file. We just created that environment, right? Oh, Paul says, is the balance of our bank account stored in a SQL database? Yes. All the SQL databases have our millions and millions of records. It's everything in the database. There is no other securest place than database itself. Well, which database it is, that's a question. Is it Microsoft database? Is it Oracle database? It cannot be MySQL, definitely, because that's free. So it has to be either Oracle or Microsoft, or whichever is paid expensive ones. But yes, every record is in database. Okay, yeah, cool. And here, so we see that they have configured the data storage, database storage separately, and log storage separately. then its a secondary replica has the same thing. So if the primary goes down within the branch, obviously the secondary becomes primary, because underlying structure is failover clustering. Now I also teach MCSA and MCSE, and MCSA is actually going to expire in January 2021. So we got what, 3 months now before MCSA expires. If anyone wants to give that exam, let me know. I'll send you the material. But okay, so failover cluster. We used to do the whole failover cluster lab in the MCSA course, and that is really it's not that easy. Obviously, it's complicated. But we used to do the crash test as well, and so in production environment, we normally banks normally go 2 times in an year. That suppose they have 2,000 servers there or 3,000 servers there, so 2 times a year, big corporations and banks, they actually fail over everything from production to DR. So they check pretty much every server, all file servers, all SQL servers, all Exchange servers, all web servers, any other servers, transaction servers. So they just simply fail over to their other branch on the weekend, and then they check it out what happened, what happens. So this is what they do as a test 2 times a year. But what happens here is if there's a disaster on the local branch level and just one primary replica is, or primary database is gone, then obviously it will fail over to the secondary. But if the whole branch outage occurred, then it will simply fail over to the DR branch, disaster recovery, and there also there's a local level of primary and secondary there as well. If local disaster strikes here, it will still fail over to the secondary as well. So 2 sites plus within the site, within the branch also, high availability is taken care of in this case, right? But this is a perfect example for the always on availability, and it's actually using the failover clustering. So I just love doing the labs, and then we normally implement it in the contracts as well. So this is the way we really learn. So I would try my best to get this working on Azure environment. Hopefully, I will be able to do that, or because at least once you should see live what's going on. Otherwise, I have the recording of way back courses where we enabled always on with an older version of SQL. So it pretty much works the same way in newer ones as well, with just some new terminology there. So this is just a discussion for always on. Oh yeah, this was going on in the diagram here. Okay, but this is available in our environment here in the SQL Server. Obviously, we need to have second SQL Server for that. So I will be deploying the second SQL Server while deploying a second instance on this machine, just to show how to deploy a second instance in this same hardware, and then a separate SQL Server as well. I cannot copy this SQL Server to another one because of the SID issues, security identifier. So I'll have to just deploy the whole thing step by step. Well, that can be done in the background as well. So, but yes, always on and replication, obviously, and the mirroring. I showed you, if I right click here and go to tasks here, there's a mirror. Now this feature was supposed to be deprecated, discontinued, but still showing up here as well. It was supposed to discontinue in SQL 2012-2014. So 2016 still has that feature for maybe backward compatibility. So mirroring also requires obviously 2 separate SQL machines, and then the replication, and then always on. So I'll be pushing for to reach the always on as well. Okay, but we understand that this is the perfect high availability because it uses Microsoft's perfect failover clustering feature, right? And there is management, and in the management normally there is policy management. You can create policies for conditions and facets. So we're going to go for management one by one and try to check all the features here. but you can create policies and conditions that if this happens, then do this, and if that happened, do that. Suppose the machine goes down, then try to start this machine 3 times and also send us an alert. So you can create a lot of types, many types of policies there for maintenance purposes and alert purposes. But then there's data collection, and obviously as it says, so you want to retrieve data from outside sources or another SQL server. So and also for maintenance level and management data that can be collected, that okay, how long, especially for the log files, then you go here. The resource governor, how much resources, how many resources are deployed here, how many SQL servers are deployed, how many databases, how many tables are deployed, all details come here. Extended events, so all the event logs. Event logs obviously tell you that, or saves all the events. If I go to tools, and there's an event viewer here in every server, obviously, and that event viewer has Windows logs, application security, setup, system logs there, and then applications and services related information there as well, and then subscriptions. So the main thing is that all the log files need to be saved somewhere. So SQL Server has its own mechanism of collecting the events that happened from time to time. And maintenance plan, so obviously when you do maintenance, so all kinds of new maintenance plan wizard, it takes you that, hey, when do you want this database to be maintained and be offline, and how frequently you want to do that. Do you want to automate that process, that every Friday night we will do some maintenance here? So schedule that, and what exact tasks you want to do in the maintenance. So that wizard just explains that. SQL Server log files, so it already has some files on for today. It has log files, so 15 October, then 9 October last time when I went, and then so it created log files, and each log file then shows exactly at what time, what hour, what minute, what second, what exactly happened, if some change was done. So all that is really detailed log files that are available here in the SQL Server logs. And then database mail, obviously you will have to attach or give some SMTP address of some messaging application, so you should get or receive emails about whatever alerts are created here. And distributed transaction coordinator is that all, if you're connected to some other application and application is sending you a lot of data, then in that case, how that you need to connect to that application, are you still connected, and some session related policies and configurations. So integrated services catalogs, integration services catalogs, that is also available here in the slide as well, where it so management tools we talked about, and R services, masters, integration services here. So integration services is a set of graphical tools and programmable objects for moving, copying, and transferring data. So you want to integrate your SQL to any other application and then start transferring some data, so that you can do with the help of integration services. It also includes the data quality services component for integration services. So about the DQS, obviously all the data is reaching from point A to B in one in in an intact form, not corrupt at all, not been have not been changed. So the quality of the data is also checked there with the help of integration services. So then SQL Server Agent, a really important tool here to schedule the tasks and alerts. So all SQL Server Agent is done is handled by our one of the system databases called Msdb. Msdb normally works with this SQL Server Agent here, right? And then the X event profiler, so standard events and T-SQL. So T-SQL is just the querying that you run here, or the scripts that you put here We're going to work on that too. But event profiler, so what kind of events are created for what exact kind of scenario here, that that information is normally placed here. So guys, that would be our screenshot number 6. That I'll just put that screen here where we can say it's a SQL Server Object Explorer. So screenshot number 6, take a screenshot here, take a screenshot here. It's object of SQL Server Object Explorer. So the name of the screenshot would be SQL Server Object Explorer. I'll try to take a screenshot now and check it out if it's working or not. Try to place here. Okay, now I'm gonna go for the snipping tool that I've not been using. Serious, that was such a simple solution. But it's not the snipping tool, it's the pasting tool. Oh, it is pasting. Seriously. Okay. So screenshot 7 would be, I'll just put it there. Screenshot 6 is the SQL Server Object Explorer. SQL Server Object Explorer. So I'll put it there in WhatsApp as well. SQL Server equals screenshot 6 equals SQL Server Object Explorer. SQL Server Object Explorer, and I'll put a screenshot. Oh wow, so it's still on WhatsApp. It doesn't work for me. I'll try to restart the machine before the next class. So that would be, oh yeah, so please take a screenshot of this screen. Screenshot number 6, this is screenshot. Please take a screenshot here, and SQL Server Object Explorer. Okay, so if the screenshot has been taken here for screenshot number 6 and its name is SQL Server Object Explorer, then let's go ahead. I'll update it there on OneNote as well. And oh yeah, I did actually updated that. Screenshot 1. Oh. Whoa, then 3, 4. Okay. And 5 and 6. Okay. I think 2 was there. Alright guys, so let's continue, and hopefully you've taken a screenshot here. So this is just a brief intro to all the components, the folders here on the SQL Object Explorer, and we also created the database, and then added the 2 disks, and then created database with vendor best practices there, and had some brief intro to all the other components of database. Then if we go back to some of the other steps, lab steps there, excuse me. So guys, there's Microsoft has released a sample database as well, and that database is having a huge amount of lots of data and lots of tables there. So what is the purpose of creating a AdventureWorks database? Because Microsoft gave the developers and the database administrators, suppose you want to run some query, suppose you want to test with a database that has a lot of data inside, a lot of tables inside. You want to test a lot of new features with those these things. So database, what is the main thing in database? A lot of data. So then how can you how can you test a lot of components and new features, and also to make sure that its replication is working, its mirroring is working, its always on high availability feature is working. Obviously, if the data inside or the table inside are affected, tables are deleted, data is gone, then how can you really trust that feature? So that's why Microsoft says that, hey, you want to do any kind of testing, I'm going to give you a sample database called AdventureWorks, which is simply a database of a park or recreation facility, and it has a lot of tables, which has a huge amount of data there. So how a company's database really looks like, you can see from this sample AdventureWorks, and then we're going to try to run some queries on that and do different labs on that. But in order to do that, obviously, since we cannot create huge amount of data of our own, or not on that level, so let's just next task would be that let's just grab that Microsoft AdventureWorks sample database from their site and attach it to our SQL Server, so we could do some labs later on a database that is actually not empty and it has a lot of data and tables. So let's do that. How do we first get the AdventureWorks dot back, and then how do we attach it to our? So that's the other slide here. How do I reporting services? And it says, well, okay, that's already. Oh, actually, it's not that. So I will just simply put those steps here. Let me just show you the steps, and there's a link there as well to download the AdventureWorks. So I'll just arrange that as well. I think I have a slide up there, but I'm just going for AdventureWorks here. Well, okay, it's kind of an adventure for me now. So I have this already open here. Okay, that is it. Now this is the link here, and this is a slide here as well, but I'm just gonna put that in how how to download AdventureWorks database, how to download and attach an AdventureWorks sample database. So that's in WhatsApp as well, this link. So I'm just going to follow this link here, and it has that sample database for SQL Server, all versions, SQL Server 2008, 2012, 2014, 2016, 2017, 2019. So I'm going to go for, and then they have all kinds of data there. You want to go for OLTP. This is for online transaction, and then data warehouse. Suppose you have huge amount of data and you want to run some advanced analytical applications there against that huge data, or as we call big data there. And then there is lightweight. LT data is a lightweight and pared down version of the OLTP online transaction protocol there. So first of all, I'll go for that AdventureWorks 2016 line here, and then there we can go for lightweight because yeah, when on Azure we want to stay light. So anyway, that's the lightweight column. I'm going to go there and select the 2016, and I'm going to click that. Now it's not a .mdf file, right? The regular database that we created back there in the SQL machine, that was a .mdf file, right? This is a .back file. So this is actually a backup file of the database, and we need to use the restore option. Whenever you take a backup and you want that data back, so you always restore, right? So we're gonna do exactly that. We're gonna actually add this database to our SQL Server with the process of restoring. So I'm just gonna click on that 2016 lightweight, and once I click that, so it says that it's gonna download. So obviously I don't need to download it inside my laptop, so I'm just gonna cancel out from there. I'm gonna go click this and copy this link. I need to download this in my Azure based virtual machine. So I'll go there to the virtual machine in Azure, and obviously I'll go for the browser here and download directly the database here. So I'll just go Google it, and yeah, so in this machine I'll download this AdventureWorks database. Click that. It's so small, it just downloaded right away. Okay, and showing bars. Okay, well, I already had that, but its size is okay. Hence, it's like since it's lightweight, so it's just 7 MB. Are you kidding me? But it has more tables here. In case that is not enough data, I'll just go for the why am I coming back with this? That side is still open back there as well. So I'll just check the size as well, and that maybe we need it later if that's not enough. Oh, it's just 45 MB. The OLTP one is just 45 MB. The lightweight is 7 MB. So yeah, I have two types of data bases here, or two sizes, and that's okay. So I need to simply attach it to my SQL Server. So that page also actually explains what to do here. So restore to SQL Server. So since it's a backup file, .bak is the extension at the end of this database. So it says that, hey, just go ahead and use the restore feature to attach this backup database. That's one thing. Second thing, it says that SQL Server Management Studio, just go there and you have to put that file in this path here. Normally the backup files are always in this path, right? So what I need to do is I need to go to this file, /program files, Microsoft SQL Server, msql15.msql server, msql server, right? And then backup, right? So I need to copy this file into that msql server, and I'll just copy this now and go to my C drive, and it says here program files, not x86, and then I'll keep the path up here. Program files, Microsoft SQL Server, there's Microsoft SQL Server, MS SQL Server 15, which is actually 13. Why it is 15? Because it says 2019 here. I should have, you can see that I can just change that to SQL Server here and 2016. So the path is pretty much the same. I just changed the version here in that page, and yes, it actually also says 15. So anyway, I'll just go back here, and it's Microsoft SQL Server 13 here in my case. Well, 2016 is 13. In the documentation, I'll just say, and then MS SQL Server, and there's a backup here. So this is the folder which opens. Now, why do I have to come here? It's not compulsory to come here. Wherever I downloaded that in the downloads folder. I could just attach from there as well. Here, when you always go for the feature of restore in SQL Server, the restore feature always directly opens in this path. Obviously, it's going to restore a file that was backed up, right? So it's going to open the backup folder first. So they're saying that it's recommended to put this file, when you download that, just copy that file into, that's a 47 MB file. Let me just go for the lighter file first. Just copy it inside this folder, and it will be a smooth attaching the database. So, oh, what am I doing? There was other path here. Yeah, backup, this one. So I'll paste it here. Okay, so guys, this will be our screenshot number 7, attaching the AdventureWorks. So I downloaded it from here. Either it any other SQL backup files are on AWS. Oh, Yeah, so they also have .bak then. In Azure, you mean? On AWS. Exactly. When you download that, I think they all have the .bak extension. So it's very easy to actually restore. That's why it's there. So guys, take a screenshot here for this screen, attaching the sample AdventureWorks database. Attaching the sample. So screenshot number 7, attaching the sample AdventureWorks database. Take a screenshot. Take a screenshot. So I'll go for snipping tool and take a screenshot of this, and take a screenshot of this. Hopefully everyone has taken the screenshot. Okay, and screenshot 7, attaching AdventureWorks sample database. And right click, paste it. Serious, Control V's acting up. Okay, I need to take that screenshot again, otherwise I'll just put that screenshot title there, and I'm not able to take a screenshot right now. Oh, it is there. I'll take a copy of this. I'll take a copy of this and wow. Anyway, nothing there as well. So I'll just put the screenshot title there, and hopefully you've taken the screenshot. It's not hopefully, you must. I need to mark something, right? So hopefully you've taken the title, and hopefully you've taken the screenshots. So the screenshot page is this. Okay. If you have taken the screenshot already, for this I'm just gonna carry on and attach this AdventureWorks sample database, but I put it already in the backup. I don't have to necessarily do that. I can just from the restore, I can go to the downloads folder path as well, but this is the way to go. Okay, once it is in the proper folder structure or path, then I'm going to go back to my Ssms here, and then I just need to attach it, right? So I'm going to go right click on the database here, and there's a restore database, right? So we click the new database before now. There's a restore database, and once I click the restore database, then it asks that, hey, where's the backup? So I'll say that, hey, it's in the device. The backup is in a device. So once I click the device, then I go for the 3 dots here, and so there it's asking it's a file or URL. Obviously it's a file, and then it's add, and yes, there you go. So since we put that database in the right path, so it's showing or it's detecting the .bak file directly here. So this is how it is. So first I went to restore database, then in the device here, then I went to 3 dots here, then I went to the add button here. It directly opened it in that exact backup folder. So that would be our screenshot 8 now. Adding the AdventureWorks database. So all the steps are pretty clear now. Adding the AdventureWorks. Can you show again how you open the window? Oh, sure. Okay, so here, cancel. I right-clicked on the databases on the top, and then went for restore databases. So once you click the restore database, and then device, then the device, I'll just try to put that here, and then click the 3 dots. I'll put it down here, then click the add button, and it directly opens in that path. So guys, that would be screenshot 8, that attaching the AdventureWorks database. Oh, wasn't that already the screenshot number 7 title? So you know, the steps to attach AdventureWorks, we can say steps to attach the adventure. So one picture just simply shows all the steps. Well, that's pretty much it. You press OK and it's added, right? So screenshot, I'll go for SQL Server. I'm putting it in. Take a screenshot here, take a screenshot here, take a screenshot here. SQL Server, and then screenshot 8, and steps to attach AdventureWorks database. Steps to attach the AdventureWorks database. That's screenshot 8. The title is there in the WhatsApp. I'll put that title. Hopefully everyone has taken a screenshot here. This screen, I'll put that title in OneNote. Screenshot 8, steps to attach AdventureWorks database. Okay, so if you have taken the screenshot already, then I'll simply select this .bak file and then press ONK, right? So if you have taken the screenshot, then I'm just going to press OK and keep on OKing here. And yes, it shows the whole path and the time. Well, we're good. So I'm going to press OK. We can check the verify backup media as well, but we don't have to. And press OK. So database AdventureWorks LT 2016 restored successfully. Press OK. So now this database, which is actually a sample database. Oh, there you go. Okay, Paul. Paul, you're doing this whole thing in the container. Very good. Nice. Okay. So, oh yeah, thank you for showing that picture. So at least, guys, you have that sample screenshot there. Oh, that's the successful one. So, but anyway, if you expand that AdventureWorks database, so and go to the tables here, so you can see a lot of tables here. Well, okay, not a lot of tables. This is a 7 megabyte, right? So the other one was 47 megabyte OLTP one. This was a lightweight. So it has few tables, but that's good enough for us as well. Otherwise, if you add that, that would also that would have much more tables there. But it's just more data there. Suppose you go for customer table here, and in customer table I go for select top 1000 rows. If I right click on the customer table or any table here inside the AdventureWorks database and go for select top 1000 rows, so then it shows pretty much the whole table, and it shows above all the columns, and the query that ran before select top 1000 and then from what table. So that from was written here, and then yes, that's a huge amount of data that you can play with, right? So that's just a sample database to which we connected here, and to run some queries on later. So this is an AdventureWorks database with the table inside and all the data already created. Otherwise, all other databases we also create. Now during the backup, during the restore of this database, we were not able to actually change the path of this database to put the database file in the database drive there, and the log file in the log drive, right? So we were not able to do that, but obviously for the main purpose was to first attach that database after downloading from Microsoft website. So we got pretty much 5 databases here, and we talked about the system databases in detail, and then we had some introduction to the main components, all the folders, containers that are there. Also, we connected from Ssms. We created the 2 drives and implemented the vendor best practices there. So this is what we needed to do today, guys. So we're gonna go for all the other. So when is the intersession? Anyone knows? It's week 8 or 9, intersession week or the reading week. And also that I asked for mail server class that if you want to have the midterm before or after the reading week. So that's a midterm after reading week. Yeah, so that was for the mail server, right? For SQL Server also, do you want it after the reading week, and when is the reading week? So there's a very big yes with caps on, and there are yeses coming now. And so guys, but guys, do you know when is the reading week? Is it week 8? I think it's week 8, right? So then we got is the 25th, okay. So we got 1 more week before the reading week, right? Or 2 more weeks. So week 7, maybe you guys already have midterm going on. So by that time, next week also we'll try to cover a lot, so we could have some of those in the midterm. Okay, so midterm for both the mail server and SQL Server. After the reading week, we'll just do the labs for now. And yeah, week 9. Be on the 3rd and the 6th. Oh, okay. So after the reading week, we can. No, I'm just asking. Do you want the midterm to be before the reading week? Normally, I ask the students in all previous years as well, and they always would that, hey, we already have midterms there before the reading week. So can we delay this to the after? So yeah, that's why I'm asking that. Hey, do you want that after the reading week? So right after reading week, we will have then the midterm for both mail server and SQL Server. Is that okay with everyone? If it's not okay with everyone, then let me know. And oh, okay. So okay, that's okay with everyone, right? So mail server and SQL Server will have that after the reading week, and I'll post all the material. Actually, whatever material is there, videos, and whatever's in the portal, in the OneNote, and also the slides. So there will be multiple choice, 25 questions there, open book, but the time will be less, 1 hour only, and you cannot backtrack. So open book, so yeah, check it from anywhere, but good luck. I mean, like, you will need that. So yeah, I'll tell you the whole thing before the reading week as well. But yeah, it will be after the reading week, everything. Okay, guys, so number 5th. How many questions? 25 questions for the midterm. 25 questions. We cannot backtrack. Once you have gone ahead, you cannot go back. And it's 1 hour, 25 questions, open book. You cannot backtrack. And whatever covered we have done till now. It's going to be just, mostly it's going to be true, false. But it could be anything else as well. Okay, so he says he missed screenshot number 5. Actually, I missed all the screenshots. So what was the screenshot number 5? And how can I recreate that? So the content from week 1 to 8. Yes, Khalid, from week 1 to 8. Screenshot 5 was databases created with vendor best practice. Oh, okay, that. Vendor best practice. So yeah, it looked like this. Screenshot 5 was, let me just okay, if you're done with this screenshot, then go ahead and upload. That's it. Seriously, what's going on? Okay, hey, you can take a screenshot. This was the 5th one. Okay, any questions? Then let me know. Otherwise, upload the files and see you Tuesday for more mail server action. Alright, bye bye. Thank you. Bye. Alright, guys, upload all the screenshots and see you Tuesday. Hopefully. Thank you. Alright, bye bye. Thank you. Yes, Amir, what's the question? So hopefully you have taken the screenshot. I'll just stop the video and shut down the machines now. So Amir says I missed the lab screenshots of the previous lab due to the subscription problem. Oh, okay. So please email me this one and try to take. Well, just email me this one. The reason, because of the subscription problem you cannot create, and we have gone for mail server style screenshot here as well in SQL Server. Just email me and it's okay. Cool. Alright guys, so see you. Thank you. Bye bye. I'll shut down the machines now.